Thanks again, Tanya, and thanks to the GSSA for this opportunity just to share a bit about Sequent and what we do. So who we are, we specialize in geoscience software and collaboration technologies. We operate in 4 different sectors: energy, civil, mining, and environmental. Our offices span across the globe, covering all the time zones. We have around more than 650 staff members. We were founded in 2004, so we're fairly young in the geoscience software space. Our users span more than 100 countries. So for the mining side, we cover the full value chain. Our software that's well known is Leapfrog and Geosoft. But today I'll be sharing more about Central, MX Deposit, and Imago, which fall within our data management solutions. And we'll be focusing on the exploration side. So let's look at the current data landscape. Some of the challenges that we face, having to take our core photographs and just store them somewhere, have them just sit there, and also not having access to historical data or even having live feed from our core drilling data or sampling data. And sharing, that's some of the challenges that our clients face before they actually adopt our solutions. And I will share more about how we can solve these problems, and also collaborating, sending emails about models and having to attach OneDrive links or Google Drive links, and having static reports that don't dynamically update. So let me just take you through Imago, which is our core photography and geoscientific photography tool, allowing you to capture your photographs seamlessly straight into the cloud, and then catalog them and then connect them to your exploration or mining activities through integrations with Leapfrog, Geosoft, and all the other major softwares out there. You're also able to then run machine learning on the images, so you're able to detect things like sulfides, RQD, core loss, and joints, and anything like that, using the algorithms that Imago can adopt. MX Deposit. Oh, sorry, what happened there? MX Deposit, it's a data management tool similar to Imago. It's on cloud-based, allowing you to capture sampling and drill hole data in the field offline, and then sync them back into the cloud. It's quite intuitive. It's not rigid, so you're able to add and remove any tables in your database, and you're able to scale it and use it when you need it. So it uses our subscription model that you can actually have for 3 months, a month, 6 months, or to a year, and you're able to customize it and also get insights from your drilling immediately as the data gets synced into the cloud. You just need a URL to access MX Deposit. It works on tablets and on computers. So Central then becomes your warehouse, your data warehouse, where all your data and your projects are actually stored. You're able to then collaborate within the teams, share models across projects globally, and create an audit trail where you then are able to generate a lot of confidence in your models and actually see who's working on what, and basically have one version of the truth. So this is the integrated solution overview. You would have your core imagery coming in from Imago that can be then pushed into Leapfrog. You're able to then connect your core imagery to your drill strings, have your drilling there with your images to validate your model. You're then able to then get dynamic updates into your model as data is logged in MX Deposit. This is using Sequent Cloud, which is a platform that connects all our technologies, and then be able to visualize all of that and manage it through Central to basically improve your collaboration, change, iterate models, and make decisions faster. You could decide whether you're going to continue drilling, stop drilling, look for other targets. You could also use it as a platform to teach junior geologists what actually the quality of the company that you work for, the standard operating procedure for modeling. And also, of course, real-time updates save the time between the decision maker and the data collector. You are then able to achieve that faster. Thank you so much. I think I might still have time, and I can show a quick video if I do have time, Tanya.
Yes, you can go ahead because Toby is not in yet, so you can continue.
Okay. All right, let me just quickly share this video of how it's actually used in the, So I don't know if you guys can hear.
Tsecha, when you share your video, share
Yes.
computer sound as well. Otherwise, we can't hear the.
Sorry, let me just try again. Advanced sharing options. Okay, let me see. Share screen to share sound. Okay, there I see it. Thanks, Tanya. I'll just leave it where it is.
Exactly like this.
Can you guys hear?
We've been using MX Deposit.
Yes.
And the Imago software app for about a year now, and it has improved our efficiency drastically. Instead of everyone having a computer with Excel that you have to save and go in and out of a million times, everyone can be logging the hole at the same time as long as you have a different tablet for it. So here you can see I have lithology pulled up, and this is top of the hole to our current position in the hole, which is right here. And if you come over here, you can see Mike's over here logging mineralization for each interval that we've already distinguished. And then as you go through, you can continue, and we even have a oriented log program here. So we have a tablet for the oriented log, structure, alteration, mineralization, RQD, sample. And that is everything we do to log this core. And as I said, everyone on their tablet can be doing a different tab at the same time, so it's highly efficient. And then as soon as you pull out of it, it all auto-populates to every computer that's logged into the program at the time. Our internet's very slow right now, so it can take a little while, but that's our only slowdown. And as we're going, we're logging, we're also snapping pictures at the same time. And we found that having consistent lighting is key to being able to capture well-lit photos. So as we go, you can come over here and see the software. This is our buddy Hayes. He's been helping us a bunch. So you just type in the new depth you want to go to, 397.3. Move the whole thing over, and then just hit the button, and you get your photo right up here. And you can see it's already cropped. It has this amazing auto cropping feature that it'll take each row and crop it individually. So and then once you upload it to the software site, it will lay them all out consecutively, so you get a nice line of your pictures as the core is going down. It's pretty amazing stuff.
So
yeah,
I think
so
I'll
as you can
stop
see,
it
we
here.
have different holes here, and you can go in, and it takes a while to load.
Thank you so much, Tanya and everyone. I think I can stop there.
So the topic of my talk is really just to give an overview of the lithium markets and lithium deposits. It's by no means thorough, so there's going to be a lot I'm going to skim over. It's quite a broad topic, and it probably is going to be a lot that I'm going to leave out. So if anyone has any questions, please shout or reach out afterwards. So just jumping in, and I'm sure people who have sat through this before have probably seen some of these slides, but it's always good just to go back to it. So lithium was first discovered back in the 1800s. Petalite was first discovered as a mineral, and then lithium isolated a couple of years later. Lithium's first real applications came to the fore in the 1940s during the Second World War, with its application as high temperature lithium greases, and then as in medications, as well as ceramics and glasses. It also, during the Cold War, was quite important in fusion bombs and the nuclear industry. And obviously these days people know it as the poison of choice for lithium ion batteries. So it's, I suppose if you look in the last 50 years, it's gone from sort of threatening to blow up the world to saving the world from global warming. So if you look at its primary applications today, they still sit in the glass and ceramics, lithium ion batteries, the greases, air scrubbing, and then a variety of other applications, including catalysts, flux powders, pharmaceuticals, and even in the aluminium industry. The last 5 years, we've seen a massive change going from a, sorry, I just want to put my nose button, going from around 202,000 tons lithium carbonate equivalent to this year, it's well over 500,000 tons. And the big change we've seen really is this shift in the amount of lithium going into lithium ion batteries. At the moment, it's sitting around 70% of lithium consumption. By 2030, they forecast it's going to be around 92% of lithium is going to be used in lithium ion batteries. So if we look at this increase in demand, what's happened, and I think someone mentioned it yesterday, there's a big disconnect in what we see auto manufacturers promising in terms of mega factories, gigafactories, and the demand that is going to necessitate, and what mining can actually supply. And from around this year, there's going to be a deficit, which is just going to grow. This blue here is really just tons that aren't on the market yet, and due to come on stream. So even with all the exploration and plans, there's going to be a huge deficit. How that plays out is yet to be seen, but it may be a case of them having to do some sort of lithium load shedding, for want of a better word. So why the demand? Well, if we look at global emissions by sector, transport is the fourth largest contributor to global emissions. So it obviously makes sense to target the major culprits in terms of converting to a low carbon energy transition. And lithium ion batteries are obviously well suited to electric vehicles. This chart, so don't worry about the numbers, but the big thing that we've seen in the last decade is lithium ion battery prices per kilowatt hour have dropped dramatically. I think this year is the first time that they're probably going to go up in a decade, just due to the price volatility in the commodities that go into them. So also, well, what we've seen over the last couple of years is a massive sort of market. EVs have gained market share in terms of total vehicle sales, and is forecast to continue into the future. So the blue is really showing this increase in EVs as part of the market share. And translating that into sort of going from the forecasts to real world numbers, you can see these red columns here are real world sales of EVs, and you can see over the last 4 years how it's increased exponentially. And according to figures from September last year to this year, there's been a 51% year-on-year growth. And currently EVs are, if you believe the figures, 17% of global vehicle sales. And I'd suggest that's probably quite well ahead of the forecasts that have been put forward. Obviously, the big elephant in the room that everyone speaks about is everyone says this transition isn't going to be clean. And this is just an excerpt from the Stanford Energy Group by Alex Grant, where if you look at life cycle assessments to make an EV, they do leave a bigger CO2 footprint. A lot of research has been done over the lifespan of an EV that they are friendlier to the environment than internal combustion engines, depending on the energy mix you use to charge them with. And this is all sort of assuming status quo with current technologies for extraction and processing. And I think what we're going to see in the future is quite a big change in how people approach these things and how the industrial processes change, become more CO2 neutral, or they start sequestering the CO2. And we're probably going to see something like Moore's law for the environment, where you're just going to get an exponential change as technologies improve. So this story, a couple of years' time, may be quite different. So if we just look at the supply chains, which is also a critical part in the whole story, and where we get these materials, lithium is sourced primarily from Australia as spodumene or mineral concentrates from pegmatite mining, and then from South America, Chile, Argentina, from the lithium brines. And then you've got China that also contributes, and the rest of the world, which is Africa. America doesn't declare any of their numbers. But again, the big change that if we went back 5 years, South America would have been the dominant supplier. But with the increased demand, Australia has been able to ramp up quite quickly to meet some of this demand. Going forward, we're going to see a big change, and the rest of the world's going to come or get with the program and start putting material into the supply chain. And this bottom chart is just showing this growth in sort of lithium supply and sort of demand, and how your spodumene is still going to continue to dominate the lithium supply chain. If we look at material flows, the picture here is quite complex, but it's pretty much everything flows through China, and then the batteries are made in Korea and Japan. And again, the next slide is going to show this same thing. I apologize for this line, it's in the wrong place, but essentially it's showing very little material is mined in China. It's all processed in China. And the world relies on China for the lithium-ion batteries. And this is lithium specific. And it really just shows how China dominates, or everything passes through China. So the world is highly exposed to the risks of China's ability to produce material. And what we are going to see in future is, and we're already starting to see it, is regionalization of supply chains, just to de-risk geopolitically, and then also reduce carbon footprints. You can't be seen really to be shipping huge quantities of material across the globe and leaving huge carbon footprints. And then also you're seeing chemical producers and auto manufacturers just looking to vertically integrate to secure supply, and then also on this life cycle will just reduce carbon footprints. So if we get to the deposit types, I'm just going to run through those. And this chart, I suppose, shows the major differences between them. And you've got, I suppose, your two primary types that are currently producing. You've got your pegmatite deposits, generally quite high grade and lower tonnage. You've got your brine deposits, which are an order of magnitude lower grade and about an order of magnitude larger in terms of tons. And then this green here is your sedimentary hosted deposits, which I'm sure people are familiar with, which are your jadar type deposits, your lithium clays, and they sit somewhere in between. And I would sort of suggest that they probably represent sort of a fossilized form of these lithium brine deposits to some extent. The classification is, while it looks quite complicated, it's really just your igneous deposits, which constitute your pegmatites and some of your other types of magmatic deposits, your sedimentary hosted deposits, which are your clays and your jadar types, and your brines, which we'll call your conventional type deposits, and then your unconventional brines. So these will be your geothermal brines, your oil field brines. And again, this purple and the gray group are not deposit styles that are actually producing any or putting any lithium material into the markets at present, and their ability to produce is highly reliant on the metallurgy and ability to extract the lithium on a commercial scale. And this chart, again, I apologize for the complexity of some of these, but you'll get this presentation afterwards and you can take your time to read through it. But really what it's showing is just how the two primary deposit types that are producing lithium, how they differ. So your pegmatites produce minerals that are then either fed straight into your glass and ceramics and your technical applications, or the mineral concentrates are converted into a carbonate or hydroxide that then make their way into the batteries and various other applications. Your brines generally go directly into carbonate or chlorides that then are used in the various applications. And I suppose your sedimentary type deposits are going to fit into this processing flow when they eventually come online. If you look at the global distribution, and this is a figure from the British Geological Survey, and the larger dots are producing mines, the smaller dots are occurrences. Your reds or your pegmatites, and you can see there's quite a global distribution of these and found pretty much everywhere. Your blues or your lithium brines, and they are quite geographically restricted to Mongolia and South America. And then your yellows are your sedimentary hosted deposits, which you see there's a cluster here in America, and then there are a couple here, and this one here is the jadar deposit. So if you just go into the brines, as I said, they're geographically restricted, generally high altitudes, low rainfall areas. Your major producing regions are South America, Mongolia, and then North America. But again, America doesn't disclose any of their figures, so you don't really have a good handle on what has been produced there. The model is a closed basin where you've got water influx, high evaporation rates, acidic volcanics into a basin. Many of these deposits are less than 8 million years old, and you get these saline brines forming on surface, infiltrating and developing these saline aquifers that are then targeted by your companies, and the brines are then extracted and pumped into evaporation ponds, and through a series of sequential evaporation and precipitation steps, you produce a lithium carbonate at the end. And these are pictures from SQM's deposits in South America. The big thing to note here is that these often take, although in desert regions, there's a lot at the moment around environmental issues on water and the impacts that it has on the communities. And then also they're quite capital intensive. They take quite a bit to expand, and throughput times from pumping out a brine from a well into producing a carbonate can take up to about 18 months. If you look at the processing, as I said, it's evaporation, but there are a couple of other new technologies developing where you've got non-evaporatic techniques. So you've got direct lithium extraction, which is a technology that has been used for a while, but there are newer processes in the works. And the idea is that you really just pull your lithium out of your brine, and you can pump in a brine back into the aquifer at another point, and without producing hypersaline brines that are potentially quite deleterious to the environment, or producing a fresh water that can then be used for various applications in the communities. current evaporation is quite, I suppose, it's not very efficient. You're only getting about 40% of your lithium precipitated out. So these new technologies, besides being more environmentally friendly, are a lot more efficient in extracting the lithium. And the big thing with these deposits is also just understanding the hydrology of the deposit and making sure that when you're pumping your deposits, how your resource reacts to the pumping, how it recharges, how pumping back your brines affects, and your aquifer and doesn't sterilize your resource. So they're more a geohydrological problem than purely geological. If we look at the pegmatite model, generally the accepted model that everyone knows is you've got a granite intruding into some sort of host rock. Granite crystallizes, fractionates off the incompatible elements that then migrate away from the pegmatite body and crystallize your various types of pegmatites. And again, a pegmatite is generally, everyone knows it as a coarse-grained rock, got quite variable grain size, text and textural variations within the intrusion. They can range from well-zoned, concentrically zoned, to asymmetrically zoned, to unzoned and pretty homogeneous. And I think the next two talks are going to probably talk, or you'll see a lot of those sort of textures and give you a bit more detail on those. The generally accepted classification is that pegmatites are classified into two geochemical groups. You've got your NYF, which is niobium, yttrium, fluorine type pegmatite, and your lithium, cesium, tantalum types. And those really go back to your source granites or your source melts, and it's your LCT types that everyone is targeting pretty much in this field here. Your primary minerals of interest from a lithium point of view are spodumene, petalite, and to a lesser extent, lepidolite. Spodumene is what they produce, your concentrates, and comes largely out of Australia at the moment. Petalite has, at the moment, large technical applications, but processes the same way as spodumene. And I think that Uis talk a bit later will be talking about, will be a petalite project. The latest models and thinking have moved away from this granite model, and you've got sort of your two models now, where you've got pegmatites formed as a direct product of anatexis, and there are a number of pegmatite fields that you find where there are no source granites that are either that you can relate either genetically or in the same temporal space. So, and this holds up quite well for a number of pegmatite fields. And then you've got your pegmatites as a result of sort of residual melts from granites that then either crystallize within the edge of the granites or around the granites. And the chemistry of these pegmatites is largely dependent on the chemistry of the host rock or the host rock from which they melt. And again, I'd suggest anyone interested refer to the papers because they can get quite technical. These are just some of the lithium minerals that you see in the field. These are some spodumene crystals. They can be quite variable in size and textures that you see. This is petalite, and again, the color can be quite variable. They can be quite tricky to identify because it looks a lot like feldspar and not always obvious. So often need to rely on XRD and chemical assay to tell you what you've got. Again, this is just, I apologize for this slide. The title is incorrect. It should be spodumene. That picture, these are pictures of spodumene minerals, large bladed crystals. These are some finer grained textures of spodumene quartz intergrowths. Why I'm showing you this is really it just has challenges when it comes to processing these minerals. So it's important to understand these sort of textures when you are dealing with pegmatites and as to how they process. Sorry. I'm making a hash of it. Moving on, this is these are some petalite textures that you see where you get some incipient alteration or some spodumene intergrowths. And again, these have quite important processing applications. And it's going to determine how fine you need to grind, what sort of plants you need to put up. And I'm sure some of the other presentations will probably get into this in a bit more detail. And this is just an example in understanding these textures, in that you can have recoveries on a spodumene project that can vary from 60% all the way through to over 80%. So again, often these projects aren't necessarily just about the chemistry or the size or the grade. And this next slide's really, it's often about how you're able to extract the minerals. This is just showing some of the size variations that you get in these pegmatites. And I've got green bushes up here. That is the largest, highest grade lithium deposit in the world in Australia. And then you've got Pulgangura in Western Australia as well. And then some African examples. You've got Uis, which is a series of pretty big pegmatites when you go and see them. And these images are all to scale. And then you've got Manono in the DRC, which the current resource is just down here. It's about 2 Ks of strike, and it's actually the biggest, highest grade unmined lithium resource in the world at the moment. And they've still got another 11, 12 kilometers of strike to explore. And then you've got Iowa in Ghana, which is also a reasonably big lithium deposit and quite high grade. All of these are spodumene projects. This is a petalite project, the Uis project in Namibia. And this is just an example of 3 projects showing quite a variation in size and grade. And it's really just to show, like often in gold deposits and other styles of mineralization, size and grade are king. These are quite variable in size and grade, but all potentially economically viable projects. This top one, despite it being high grade, is actually a lithium mica project and probably the most challenging of the lot to mine. The other thing to note is that often these deposits have byproducts, tin and tantalum as credits, which also add to the economics and needs to be considered in the projects. And that's not even then there's also your industrials like your feldspars that you need to take into consideration. Getting onto the sedimentary hosted deposits, these are your sedimentary clays. The model is that they form in sort of volcanic calderas. You've got hydrothermal circulation, leaching lithium and depositing it, precipitating it into the clays, or getting it absorbed onto the clays. You also often have evaporites forming within these deposits, and you often see that in the geological record when you drill them. So the view is that they are probably fossilized lithium brine deposits to some extent. You've got Jeddah, which is quite unique and very high grade, very large. Incidentally, jadarite, the mineral, has the same chemical composition as kryptonite, which is quite sort of ironic considering the problems that Rio Tinto have been having with that deposit and getting it developed. And often they're boron credits with these deposits. So you'll see a lot of those deposits up in the Vadar region in Eastern Europe, in the Balkans, also have lithium credits that many of the operators are looking at the moment. The big thing to note with these deposits is none of them have actually been mined. They are sort of works in progress. So, and many of the extractive techniques that have been looked at are sort of direct lithium extraction or leaching and sort of heat pad leach type operations. The other thing to note is that they do often have carbonates within the sediments, so they can consume quite a lot of acid and potentially release a lot of CO2. So those are things that need to be considered when looking at these deposits. This is just a picture from Rhyolite Ridge, quite a thick sort of lithium boron bearing zone. And in my opinion, pretty unspectacular when you compare it to what you see in a pegmatite. But I think if they get the processing right, they're probably going to be quite easy to mine when it comes to mining them. Then you've got your unconventional brines, where you've got a bit of lithium, and it's usually a few hundred ppm in these types of deposits. So often, like in the geothermal brines, they're primarily energy companies looking to produce lithium as a byproduct. And again, some of the challenges they have are the extraction and getting that right, and then also presence of dissolved CO2 in those in the brines, and even hydrocarbons, which are potentially environmentally deleterious. Well, they are environmentally deleterious, so will need to be dealt with when it comes to processing them. If we just look, I suppose the question is, are all deposits equal? And I think just in summary, your brines are generally large, low grade, they're cheap to mine, but high costs to start up and slow to production, and can have quite a complex metallurgy. Despite them being brines, things like magnesium in the brines can be quite problematic, as they tend to precipitate out with your lithium salts. And it's one of the big challenges Bolivia's had with theirs, and probably why those resources haven't been developed to the extent they should have been. Your pegmatites, again, understanding mineralogy is key, understanding the textures is key. They're generally smaller, higher grade, easier to mine. They do leave holes in the ground, and there's a lot of NIMBYs around at the moment saying, well, we don't want dirty, dusty mines, but we do want EVs, so they need to work that one out. Then you've got your sedimentary hosted clays, which again, going to leave a hole in the ground. They're a bit of a processing challenge. And then your unconventional brines as well, which similar challenges to clays in terms of extracting the lithium. And then some of the other issues I raised a bit earlier. And this table, I'm not going to go into, you guys, everyone can read it afterwards, but it just summarizes what I've discussed. Just, I suppose the big question is, how does Africa stack up with the rest of the world?
Sorry, Mike, you have about 5 minutes left. Just a heads up.
On my second to last, third to last slide. So how does Africa stack up? Well, the purple are the African projects. The greens are some of the clay deposits that I've just put on to illustrate, but these are all pegmatite deposits, just because Africa has a wealth of them. And you've got the Ois pegmatite deposit here. You've got the Kamativi dumps from Zim here. You've got the Helicon Rubicon project here, which is a lepidolite project, pretty small. You've got West African project. You've got Manono here, which is in the DRC. And then the West African Mali projects up here. So I think Africa is pretty well endowed in terms of its pegmatites, but it remains pretty underexplored and underdeveloped. And I think there's a lot of opportunity that a lot of explorers have jumped onto, probably a bit late. The Chinese are also quite active in Africa. Wherever you go, they're literally just mining the material. They're not even bothering to explore. You often see hordes of artisanal miners hand cobbing material and packing it into bags for the Chinese to take out. But I think if Africa looked to develop it, they could take a leaf out of the Australian playbook and look to develop some of the downstream processing and add a bit of value before it gets shipped off to the rest of the world. So I suppose just how the industry's developed the last couple of years, we've seen demand for lithium-ion batteries through the gigafactories expanding. You've seen increased vertical integration by downstream users, auto manufacturers, chemical producers. Been a lot of price volatility and elevated prices, which obviously creates a nice incentive for explorers. The pricing has generally been quite opaque, but there are moves to sort of make this more transparent, and you see a lot of spot price deals going through now in the past, and a lot of the stuff is sold on contract. Continued investment in unconventional deposit styles. We need to between supply and demand. Again, there's been this accelerated demand and adoption of EVs. Supply chains are looking to regionalize, which bodes well for places like Africa. And then also massive government expenditure and maneuvering to regionalize supply chains and declare lithium as a critical mineral and develop resources locally. So I suppose, in conclusion, Africa is going to become more important within the supply chain. With some of these other points, I'm just reiterating what I've already said. But I think the lithium industry is here to stay. Lithium-ion battery technology is a well-established technology. So people have invested a lot of money in the technology and aren't necessarily going to move away from it in the near future. But I do suspect that there will be some competition from other technologies going forward. But thank you.
Thank you, Mike. And any questions for Michael? I'll take us. Oh, there we go. Yes, Mary?
A question here. You mentioned, very good talk, thank you so much. You mentioned developing downstream processing before shipping. I suppose the question is, what can be done? I mean, looking at one of the graphs that you showed, how China is dominating, what portion of that processing can actually be done at home?
I think a lot of it's got to do with access to energy and access to things like sulfuric acid. I know the guys at AVZ in Manono are looking to produce like an intermediate product, lithium sulfate, which you obviously end up with a higher lithium bearing chemical that you can ship. So your shipping costs come down. You don't necessarily want to be producing a hydroxide in Africa because hydroxide's got a limited shelf life and you still need to ship it. But something like a sulfate or even a carbonate, like a technical grade carbonate, could be produced and then shipped and reprocessed closer to where they're putting the batteries together. And so things like that need to be considered. And again, it brings me to the point where Africa has actually got to get with the program, because we've got a big auto industry, say in South Africa, that's at risk of becoming defunct if the world adopts EVs and moves on. We produce about 3/4 of our vehicles we produce are shipped offshore, and the rest of the world's not going to want those if you believe all the figures.
Certainly, I'm going to talk to you about part of the overall in southern Namibia, and in particular, an area that we worked on to determine the geology and the resources. I'd like to give credit to my co-authors, Constant Petzer, who did the resource modeling, and Johan Hutting from Creo Design, who did early stage exploration and some of the early exploration reports which he signed on to the Australian Stock Exchange. I'd also like to give credit to Lopsa Pepler, who showed us around on site, and his excellent MSc thesis on the geology, mineralogy, structure, and aspects of the Swanson Tantalite deposit. This was through Rhodes University as part of the MSc exploration, and want to really understand what's going on in this area, which I refer you to his excellent thesis. I didn't see him online this morning, but any really in-depth questions that you'd like to ask about the geology, I'm sure Lopsa or Johan would be happy to answer. I'll do my best, of course. So they will certainly be able to insights that that I might not be able to do. First of all, a disclaimer, because we're going to be talking about mineral resources. These resources were signed off under the JORC 2012 code. The three competent persons were the three mentioned, with myself acting as lead competent person. Also gives me an opportunity to mention the company, and thanks to them for permission to present this presentation today. Arcadia Minerals, they are listed on, and the competent persons report that I'm going to be drawing from for this presentation are all on the website that you can see shown there at the bottom. They have other projects in Namibia, and those are shown on the right-hand side. They, in fact, have some lithium in brine projects that was perhaps mentioned previously, but the one that I'm going to be talking about is part of Namibia, as indicated in that. Just going to close down this box because it might be showing on your screen as well. Sorry, there we go. And it's showing the Swan project. They also have the Kum project, which is a very interesting one as well. What else? The going feasibility study at the moment, so that is a successful one, as we expect it to be. They'll be declaring all reserves on completion of. The project itself is owned by Orange River Pegmatite, which in turn is 80% owned by the Arcadia Minerals, which I mentioned. They own ORP, own exploration prospecting license 7, which I'll show, which the project is based, and they have applied for a mining license over part of that exploration license. So the broader general geology area, it's situated in the province, and I'm not sure if you can see very clearly, but there is gray road is where the project area is, and you can see here the share zone coming through there. The pegmatites are, if we're talking about, are actually situated to the immediate north of the porphyry share zone. But there are many pegmatites in the area which cover about 16 kilometers wide and about 450 kilometers long in this whole area, extending from Fields Drift to Kenhardt in South Africa. They curve several 100 meters long and up to 20 meters wide, although the ones that we're going to be talking about are generally a lot thinner. They're lenticular, they're sheet-like, they're mostly concordant to the regional fabric, although some do cross over. Quite a varied composition, internal structure. The ones that we're going to be talking about are unzoned, but many of them in the area are zoned. They generally would quartz with various minerals, of which some are economically interesting in our area: columbite, tantalite, and lithium. Structural setting isn't well constrained, but I think recent work, especially by LOPSA, has helped to bring forward a lot of the structural constraints, and in particular with the age dating, accepted as around a bit years ago. Generally competent host rocks, of which most of them are sort of metamorphosed gabbros. The metamorphic grade increases towards the east, but we are sitting at sort of regionally unmetamorphosed rocks here, sort of upper green schist facies to amphibolite facies rocks. The pegmatites themselves, the origin of them is generally accepted to be intrabasinal, so through anatexis, but I think that is still up for debate. So that's on the regional setting. Let's go a little bit closer in. This is the exploration license itself. It's large. Within the exploration license is a mining license owned by another party, which is Kazera Minerals, the AIM list company, who are actively mining the same or similar pegmatites or the same pegmatite for lithium. The exploration area that we're talking about is fairly small within the huge exploration license area, and that's shown sort of yellow and reddish over here. So just quickly on the deformation, 6 phases of deformation have generally been defined. The first, well, D5 and D6 generally aligned with the shear zone. I haven't shown that there, but it would be to the south of this area and cutting through the exploration license. And the E4 is generally associated with the formation of pigments, but that could also be late in age as well. The first rocks are generally about 1700 to 2 billion years old. But the deformation and the of the pegmatites is 1 billion years after that. It's rugged terrain, because your outcrop is not only very, very good, spectacular, and also of the profile shows really what the area looks like. The mine area is over to the left here. That looks towards Warmbad, a little village on the road. If you turn left from Warmbad, you get the main highway down there. We're 18 kilometers from the South African border to the north, and on the project area is on a tributary of the Homs River, which drains into the Orange River. Rugged and mountainous, access is challenging. You can see some of the smaller ones are right there, and it's arid. It's actively eroding. Just in terms of the topography, the highest peak is Signalberg, which is not shown here, but it's about 1,000 meters. And it's situated within the Tantalite Valley complex. As I showed you in the previous slide, this area is the Tantalite Valley complex. Yeah, just 2 further slides of the area. One from the air here that shows a little bit better the drainage basin. That shows the study area, and this is up off that study area, and you can see the pegmatites have been historically worked, and this is looking east, and there you see the Tantalite Valley complex mountains in the background. Historically, the area has been worked for mainly for barite and a little bit for tantalum, and not much for lithium, as I'll show you why. This is a very good view of the pegmatites. They are thinnish, so on average about 2 meters laterally, and they tend to be broken up occasionally by faulting, but they traced for 4 kilometers on surface and actually mapped as such. The history of exploration back to the early sort of 70s and 80s, when the Swanson claims, or the Swanson project, is mined the 1970s to the 1990s in a way, and time spodumene as well. The big exploration development was in 1981. NASA got involved. And over 6 to 9 months, they of exploration, including mapping, sampling, etc., and wrote a very good report, declared in those days possible reserves. Then it was sort of left alone, but more recently, the Geological Survey, in collaboration with the Council for Geoscience of South Africa, conducted an excellent mapping exercise from 2012 to 2017, broad area, the public domain on this particular area. P picked up the license, EPL 547 in 2019. They targeted 15 of the previously sampled pegmatites, and they conducted a more detailed mapping, sampling, and drilling program. And that led to a maiden mineral resource estimate was 2021, in which we are updated in March this year. And this presentation is based on the report, and in particular on the March report. How was it explored? Now you can see one of the pegmatites. They exhibit very, very good handwall contacts. You can't see the footwall contact there. You can see a vertical trench. The pegmatite sampling was by diamond saw. You can see in the bottom left down, and was cut perpendicular to the pegmatite, 0.5 meter intervals. There you can see one of the pigment, a little river P, and there's a hole going down that's still marked, and all the boreholes are shown. And the portion is Lobster himself, vessels, and with core boxes laid out for inspection. This shows what the pegmatites were named from A to G, from west to east, and this E pegmatite, and you can see characteristically a very, very sharp hang contact. We got the footwall contact because it's covered mostly in rubble here, but also very, very sharp contact. There's no visible exposure of any quenching or quench margins on that contact, and you can see even visually there's no zonation in the pegmatite. These are metagabros and pretty uniform throughout the deposit, the hanging wall and the footwall. So the estimates we focused on a fairly small area of the overall exploration area. We focused on what we call the D, E, and F pegmatites. In general, they're 1.5 to 2.5 meters thick. They're tabular, they're non-zoned, they dip gently to the east, and the economic minerals that they contain are tantalum, niobium, and lithium, as I've said. The minerals have a general progression. Tantalum, for example, increases to the east, and lithium increases to the east. They are cut off on the northern side by a northwest trending mylonitic zone, which is sympathetic to the Pofada shear zone. Some views of what the rock looks like. They're massive white to grey. You can see they're greyish quartz. Feldspar, some fairly big laths of feldspar. This is a sort of typical view core of what they look like. And on the left, you can see spodumene crystals. You can occasionally see beryl, apatite, garnet. I never saw beryl and apatite, but I saw garnet and biotite. I saw a little bit of fluorite in hand specimen, of course, and I never saw bismuth. But obviously, microlite and tantalite, you can see the picture of, tantalite crystals can cluster. And here are it's a very, very high specimen of clustered tantalite crystals. So this slide shows a cross-section, typical cross-section, and you can see they're tabular, dipping gently to the east, exposed on surface, and with the topography, obviously, you've got to drill down to get into them there as well. Just in terms of classification, I think Michael mentioned this, but They are, even though they are unzoned, they are classified as LCT pegmatites, and that's the lithium, cesium, tantalum type. But as I said earlier, that they are unzoned. Turning to the resource estimate, we had the D, E, and F pegmatites, and you can see that the black dots are the exploration holes. You can see the boreholes situated over there, and then the outcropping samples that we had that were acceptable to the overall estimation process. We did a lot of work on making sure that we were happy to combine outcrop samples, channel samples with boreholes. At the end of the day, from a statistical point of view, we were quite happy, and also from the QA, QC procedures that were followed through both sets of data. You can see, though, that you've got a fairly dense outcropping number of samples that we used in the estimation, and then a little bit more sparse when it comes to the boreholes in depth. We now call them this in the middle here, do join one in the same. You can see that on the right hand side, this is actually the model in Leapfrog. I won't show it to you live, but that was built by Constant. It's very tricky because especially the D pegmatites, which are shown, this is in the different direction to that one. So that's F, E, and D. Especially the pegmatites, there is a little bit of bifurcation, and the D, what we call the D0, the D1 and D2 do join up. So the actual modeling, those of you who've done modeling before, it can be quite tricky. It was a little bit easier in the E and Fs, which do not bifurcate. There were a couple of faults to be modeled. Those were handled in due course by Constant himself. Let's look at some statistics. Let's first look at thickness on the left-hand side. So we're dealing with 319 data points, and that's the histogram of total thickness. And you can see the mean of 202.05 meters, and with the maximum thickness that we had of close to 10 meters. However, thick zones of pegmatite are fairly few and far between, and they generally cluster around the mean of about 2 meters. If we look at the individual pegmatites, so this is the D, you might just be able to see the D there. You can see it's thicker than the others, it's 2.77 meters thick. Your E pegmatites are thinner, they're 1.5 meters, and the F a little bit thicker, 1.7 meters thick. In terms of bulk density, it's fairly closely clustered around a mean of 2.4 with a very, very low coefficient of variation. So we were pretty happy with that. And we did the same analysis for the host rock as well. Turning to the grades as well. Similarly, this is all hands, the D and bottom left is E and bottom is F. And you can see that you have these on ppm, that overall grade of about ppm with a very, very nice distribution and a coefficient of variation quite low of about 0.4. You can see the progression in grades from D of 383 to E a lot higher at 574 and F at 531. But also very, very good distributions, close to normal distributions, very low coefficient of variation of 0.4 and 0.3. If you look at tantalum to niobium correlations, what is very interesting is that the D pegmatites shown in blue here follow a different distribution to the E and F pegmatites. E and F are clustered together but DE shows a very different distribution. Also of interest is that the D contains economic proportions of lithium, still to be determined through the feasibility study and the extractability and where that's going to be processed. But the E and F have, as I'll show you in the resource table, have quite low lithium contents. So the tantalum niobium correlation is dependent on seam. I don't have an explanation for that, but there might have been a different time of emplacement. There could be various explanations for it. This is the leapfrog model. On the left, you see the D pegmatites. That's the outcrop in dark blue. So we have 3 of them, the D0, the D1, and D2. And you can see here the D1 and the D2. There's a certain amount of bifurcation and coalescence taking place over there and over there. And you can see a bit of the D into the hanging wall as well over there. So from a modeling point of view, it was quite tricky, as I said. From a mining point of view, because most outcrops and as close to surface, it's not going to be that difficult. It's all going to be in open pit. The E and F pegmatites are a lot more well behaved, a lot tabular. They don't bifurcate necessarily. And you can see the red shows the outcrops and dipping into the mountain on the left-hand side there. This was one of the biggest surprises that I had in the modeling side. I didn't expect decent variograms. In fact, I expected nothing. I thought of the mode of emplacement and the nature of the pegmatites wouldn't give me any statistical continuity, although you could see geological continuity very, very clearly with your naked eye. In our crop, I didn't expect statistical continuity, but we had reasonably well structured variograms for tantalum, not so well for niobium and pretty poor for lithium. But for the primary mineral that we were interested in, we got good variograms with ranges up to 70 meters. You can see there, and here up to over 100 meters in places. So that's pretty much the geostatistical view of it. As I say, quite surprising, but it allowed us to use kriging for the estimation and allowed us to. Yeah, 5 minutes.
Sorry, yes. You read my mind.
I've got 2 slides left, so you're spot on time. Give us time for a question or two. And so we used ordinary kriging for the estimates, and just to show you what they look like. Remember, this is very much based on the initial exploration, but your indicated resources at 1.1 million tons with a 541 ppm tantalum content, and you can see a fairly low lithium compared to what we've seen before. It's gone up quite a bit from the September 2021 estimate because of all the additional drilling, but in addition to that, about 1.4 million of inferred, and we based inferred on the variogram range and largely on extrapolation. You can see some very good grades in the inferred, so there's a drilling program planned to actually increase this resource. Does it stack up? So this is on tantalum only, and these are world tantalum deposits just selected also from the United States Geological Survey, their 207,017 database, and it's a very high grade. So that plots up here and probably in the middle in terms of tonnages. What's important is that it complies with the Dodd-Frank Act, which, as you know, is there to restrict the production of conflict tantalum, especially from the DRC. I'm going to go through the properties and uses, but the essential one is that its main use is in tantalum capacitors. So you wouldn't have a mobile phone without tantalum, or in DVD players, video games. It's a hard technology or technology critical element. I think Mark Burnett mentioned these that's protected and sought after by the European Commission. It's what Frank acts. Some pictures of the rocks in the porphyry shear zone and all those beautiful flood and morphism in the porphyry shear. It's that I think every student should go to at some stage or another, because there's some incredible structures in there. With that, I'm open to questions. Diego, if we have a minute or two left, happy to take a couple.
Thanks, Matt. Stefan has a question.
Yeah, thanks, Matt, for an excellent talk. I do know the adjacent area because I worked on Tantalite Valleys. I think you might have when you were with Severin Southern Sphere. So that goes back a few years. I wanted to ask, well, first of all, congratulations that you got that variograms work there, because I think you're probably aware that at Tantalite Valley, when they were looking at tantalum only, they weren't looking at lithium, they were drilling on a grid of something like 10 by 10 or even 10 by 20. Because you've got complex LCT zonation there, which you don't have here. So I wanted to ask, what do you think what sort of drill spacing do you drill on to get indicated resources here? That's the first question. And then these are relatively thin pegmatites and you have a considerable amount of overburden. So isn't the stripping ratio going to be a potential threat to the extraction costs?
All very good questions. There are zoned pegmatites in the area. None of them that we worked on were zoned. And that could be a contributing factor to the fact that we got variograms. It was the big surprise of the exercise to me. We drilled on, it's variable, but the drilling is on 40 meters, but the outcrop spaced sampling can be on a fairly close, within 5 or 10 meters in some places. So we've got a mixture of very closely spaced sampling on outcrop, and then you've got to mix that with 40-meter spaced drilling. You'll notice that there aren't any measured resources, and we wouldn't have closer spaced drilling for measured resources, but we indicated it's fine. There was another question. Sorry, I think I've missed
overburden.
one. Pardon?
The stripping ratio.
Oh, yes. Stripping ratio is going to be an issue. You've got mountains to move, and so we are doing some very careful pit optimization studies, multiple scenarios at the moment. It's not an issue with the deep pegmatites, but the E and F, it certainly is an issue, and we are in the process of working on that one at the moment. It's high value ore, as you can imagine, so it can sustain a fairly high strip ratio, but the economics are quite dependent on that. And as you would imagine, on trying to get the mining costs down.
Yep. Okay. Thank you very much.
Good question. Thanks.
So it's a tin, lithium, and tantalum deposit. And for today, I figured instead of rehashing the same presentation that I did in 2019, we'll have a look at what we found, what we're looking for, and then luckily I decided to include a little bit on the lithium mineralogy. So what Michael alluded to is mentioned as well. So first things first, this is just that slide that says, you can't necessarily take what I'm saying for granted, but hopefully you'll believe me. A quick overview. Let me see my pointer. Essentially, Afriton's got 4 active licenses in Namibia at the moment. We've got 3 mining licenses, being the Weiss mining license, B1C1, and 9 Ice. We've also got an exploration program, license called the Brunswick West license. The 3 mining licenses are lithium, let's say pegmatite hosted. They all have tin, tantalum, and lithium to various degrees. And then the Brunswick West license is tin tungsten with copper, and that's a vein hosted deposit. So to put into context for you, we're going to be focusing on 134, which is our West license, and that is the northeasternmost portion of the West Cape Cross pegmatite belt. That belt essentially goes from Uys all the way down to Cape Cross. And we've got the end portion, which I think is pretty spectacular. Hopefully you'll think that it's got some potential by the end of this talk as well. The 133 license down here actually sits in the 9 Ice pegmatite belt, which is the one that's adjacent. That 9 Ice area contains the historic tin tan mine. However, we do think that there's some lithium mineralization there as well that we're busy having a look at. So on to ML134, which is our Uys mining license. So the license area is actually 18,000 hectares, which is really big. First tin mineralization is reported from 1911. That was alluvial tin. Upon further investigation, they traced that back to the pegmatites. And by 1958, this was acquired by ISCOR through its subsidiary in Namibia called IMCOR. That mine continued up until 1990. During the last, let's say, 20 years, ISCOR had undertaken a large amount of exploration in that license area. We've managed to get a fair amount of that info as well. I'll elaborate on it shortly. And what they'd done is they'd actually mined 14 pegmatites through 10 different open cast pits. All of the mining that's historically occurred here focused on the tin and has been open cast. Afritin acquired this license in 2017. And then we decided to do two things. The first one was expand on our resource. The second one was to go and put up a processing plant. So we put up a pilot plant, well, what we call a pilot plant. It's an 80 ton an hour plant that's hit nameplate capacity in 2020. Recently, we've just announced that that's now increased to 120 tons an hour. What you see on the left here is just an image showing all of the historically worked pegmatites and pits, the red ones. And the orange pegmatites you see around them are the pegmatites we've mapped, but they've not historically been mined on a large scale. So when we got to Uys, we saw that it had obviously been mined by ISCOR, and we found a whole bunch of drill collars all around the area. So we did some research and we found a large amount of this historical data. Of the original 1,400 drill holes that ISCOR drilled, we had the surface survey information, the downhole survey, geological logging, and assay information for about more than 800, let's call it 900 holes. The first thing we did was we had a look at the V1, V2 pegmatite because it was the largest historical resource. And in 2018, 2019, we drilled validation drilling. So what we did was we digitized all of the ISCOR information. We then went and modeled it. We drilled holes or validation holes between the drill information to prove that the historical information was statistically correct. Likely it proved to hold up quite nicely. And we also did some down dip extensions. The result of that was essentially a geo-compliant resource for the V1, V2 pegmatite that came to 72 million tons, containing 95,000 tons of tin, 6,000 tons of tantalum, and 450,000 tons of Li2O. This resource was done on a tin-only basis, using an average tin price of $30,000 a ton. When we announced it, the tin price was low, and everyone said, "Why did you use $30,000 a ton? That's pretty punchy." And then at the beginning of this year, the tin price was $45,000 a ton, and everyone said, "Why did you use such a low estimate?" So that's the joys of exploration. The resultance of this was that we ended up with a measured, indicated, and inferred resource for tin. However, because there was historical assay information for the tin, however, for lithium and tantalum, we could only get an inferred resource. We are currently finalizing a infill drill program for the lithium and tantalum, and I'll give you a little bit more information on that later. So looking at the Weiss pegmatites, what we have is essentially modeled now all of the drill information that we got from ISCOR. Initially, we focused on the V1, V2 pegmatite, which is where our resource sits. And you can see a cross-section of the ore body on the left there. In the middle, you can now see the wireframes of all of the pegmatites that we've modeled. And the little lines on there are actually the drill holes which were validated. And the image on the right just shows the location of our processing plant that we put up and gives you a little bit of indication of how the pegmatites are spread out. We also did a mapping program, as I mentioned. We found that 180 pegmatites around the Weiss license within 5 kilometers of our processing plant are mineralized with tin. We plan to investigate those further moving forward. Now, the validation drilling we did on the V1, V2 pegmatite was done 100% core drilling. And as you know, diamond drilling takes longer and costs more. Our current validation program, which we've just undertaken, was a 50-50 split and shows that our RC drilling and diamond drilling are both representative of the core. So what we plan on doing is validation drilling over the remaining pegmatites to validate those holes. And we're going to go for an 80-20 split between RC and DD. That should cover all of the remaining 9 pits which were historically mined. During our mapping phase, we obviously looked at mineralogy, and we saw that the pegmatites all have a very similar composition. So we're going to call them typical Weiss pegmatites. These pegmatites are not zoned, or would be what you consider poorly zoned. So just as a summary at the bottom there, we had 142 historical drill holes over the V1, V2 pegmatite. You can see them in green on the map. We drilled 26 validation pegmatites holes, and that gave us a maiden resource of 71 million tons. So what we have left now to validate is about 750 drill holes. It's going to take us about 170 infill drill holes, and what we're going to get out of it remains to be seen. Here's an image just showing the planned drill holes for the next program. It's going to be quite extensive and take a while. Hopefully with the RC drilling, we can do it a bit faster. We aim to get our tin resource within measured, indicated, and inferred, as we did with the V1, V2, and hopefully we'll get a inferred lithium and tantalum resource at the same time. What we'll also do is confirm our lithium and tantalum mineralogy within the different pegmatites. So that's just an overview of kind of where we are and where we're going with regards to our exploration program at Weiss. The next little step is just looking at some of the metallurgy and what we found within pegmatites. So what you can see in the main picture there, that's the V2 pegmatites. The little circle on the side there is a person, to kind of give you an idea of the scale. The V1, V2 pegmatite is up to 90 meters thick in terms of true thickness. Our best intersection was 167 meters, but that's because it was on angle, so it was vertical instead of true thickness. The great thing about the Weiss pegmatite is that it's coarse-grained. Our cassiterite liberates essentially at 6 to 8 millimeters, which in terms of tin processing is massive. You can see some of the grains in the middle picture over here. And that's the concentrate we currently produce. In addition to that, the tantalum concentrates with our cassiterite, and we're implementing a tantalum separation plant, which separates that through magnetic separation. To date, we have done lithium test work. We've managed to concentrate petalite through both DMS and flotation. The best grade we've gotten to date was 4.5% Li2O. Everyone says, well, you've got petalite, you don't have spodumene. And what I've put on here is a little chemical formula for petalite and spodumene. And my favorite thing here is to say, well, do you know what the difference between petalite and spodumene is? And they say a little bit of silica and oxygen. And I say, well, not really, it's actually 80 degrees Celsius. The reason for that being that all spodumene processed for battery grade lithium is roasted at about 1,100 degrees Celsius. That roasting converts spodumene into beta spodumene, which then makes it more amenable to leaching. If you take petalite, you put it in the same kiln, you increase the temperature by about 80 degrees Celsius, you roast it for a little bit longer, petalite also converts to beta spodumene. After that, the process is exactly the same moving forward. So on the lithium mineralization within the V1, V2 pegmatite, which is where we've got most of the information, the pegmatite, as I said, is poorly zoned or unzoned. XRD, we've done a fair amount of XRD and lithium concentration work on it. And what we found is that most of our mineralization is petalite. It's at 70 to 80% of the lithium contained within the ore body. We also have additional minor lithium minerals, probably spodumene or lithium phosphates, i.e. montebrasite, and lithium clays. That's especially in the near surface weathered area where your petalite and other lithium minerals have formed into cochites and other clays. What you can see is some images here of what we found in the core. We found some very interesting colors from green to blue. And what you can see down here is some spodumene crystallization on the edges. The nature of this ore body is that it is megacrystic. Next one. So here's some images of the core showing the various lithium grades. We've got a meter here that goes at 0.57% Li2O, some decent tin and okay tantalum grades. Whereas 4 meters above it, we had a meter that was at, let's call it 2.8% Li2O, lower tin grades and lower tantalum grades, and the following meter had high tantalum grades. So we've got a lot of variability within the ore body, and a lot of that is due to the megacrystic nature. So some of our pegmatites, or rather the feldspars here, are up to 1 meter in length and 40 centimeters wide. So if you put a drill hole down one of those, you end up getting no grade really, but if you go 40 centimeters to the side, you could intersect some really decent information. And that's one of the things that we've really had to kind of deal with while we've been exploring. And that's just a bit of an overview of the West Tin Mine, where we are and what we're looking for moving forward. Thank you very much. Any questions?
Thanks, Tim. Any questions for Tim? If you do get questions, you can pop them in the chat. Oh, there's Prof. Judith. You can go ahead, Prof. Judith.
Thank you, Tim, for an interesting talk. When you're mining, are you doing selective mining for tin, or are you mining everything? Are you mining sort of specific zones that you've identified? Can you elaborate? Thank you.
Great question. So basically, when we're mining, what we do is we're selecting our pegmatites only, but we're processing the entire pegmatite. The reason for that is on a meter basis, we have a large grade variability. However, when you're looking at the smallest mining unit, which is 5 by 5 by 5, the grades average out and the variability is about 12%. So you're looking at, let's say, 150, 160 ppm higher would be considered high grade, and 160 ppm lower is low grade. When it comes to total tin content, it's better for everything to go into the plant. The next step on that would be that the lithium, tantalum, and tin don't all occur together. So as those separation circuits come online, by high grading one of the minerals, you would end up low grading the rest. So it's better to just process everything through the plant.
Okay, thank you.
Any other questions?
Morning, Tsuhu. One for myself.
Morning, Wilson.
Yeah, Tsuhu. Tim, thanks. Nice presentation, man. On the pegmatite, do you get, in terms of, because I saw you spoke about spodumene and petalite, do you find any lepidolite as well there?
In the West pegmatites, we've only seen the lepidolite right at the end of the fractionation sequence, only in thin section. Most of our micas are really, really clean, so they're pretty much white. And we do assay for them, and the lithium content goes up to about 0.2% Li2O. So it's not considered a lithium source.
Well, what's your cutoff?
In terms of what we consider a lithium source for, it's probably about 2.5% if you're looking at lithium in mica. We're not looking at that specifically because most of our lithium is within the petalite.
Okay, which is around 2.5%.
Well, we've done a lithium concentrate of petalites only that hit 4.5%.
Oh, okay. Well, that's good. All right. Jeez, you're in some good rich area.
Oh, yes.
Yeah. Now, congratulations for you and the team, man. All the best.
Thank you.
Hi, everyone. Thank you so much for the speaking opportunity. I'm Megan. I see many names that I recognize. Hi, everyone. So a quick overview of Acquire, Geological Information Management Software. Our vision is to lead in solving data management challenges for all the evolving needs of our customers and scale with them. So we've been in the industry for over 25 years. We've got experience working with exploration, resource development, or mining companies who rely on our solution for profitable and quality business decisions. Over the last 25 years, we've built up and maintained really strong partnerships with over 24 specialist technology vendors. This will provide you with a comprehensive range of integration and data transfer options, ensuring greater connectivity across mining value chain for your data. And it's easy to use in your data modeling, your mine planning software. So we're the experts with managing the data. We don't play around with other things, but we play well with other softwares. We've got with over 25, over 450 installations of GymSuite all over the world, over 220 organizations in 45 different countries. And these clients provide us with knowledge from all over and influence the growth of our technology to make it fit for purpose. And 7 out of 10 of the world's largest mining organizations are using Acquire's GEM solution. Like I mentioned, we are fit for purpose. Our leadership teams are mainly geologists, and we pull a lot of knowledge from the industry. We've got 24 hours, 6 days a week, multilingual global support in 5 offices in 4 continents. You can see the offices at the bottom of the slide. We're in Joburg and Ilovo, so if you're around, say hi. We operate as one company. We've got backing from Constellation Software in Canada, so we're well funded for future research and development projects, but we operate with consistency within our values and customer support throughout all our offices. So common industry and geoscientific information management challenges, but we all know it's no single source of truth, lack of consistent business rules and processes, database version issues, multiple data formats. You've got your loss of IP through that person who holds onto the IT and leaves, or then there's no data champion, there's no internal capability to support your data management solution. Another challenge is poor process documentation and design, as well as connectivity. We all know how it is, like connectivity issues. Also with transferring your data, you run the risk of losing your data, or your data gets corrupted. And of course, the challenging cost situation. So with GymSuite, this is the umbrella. We've got, you can manage your geological information via desktop, web, and mobile under one umbrella. And with our Arena, that's a native mobile data capturing application, allowing geologists to log their core offline on Windows devices, and it syncs automatically to the database once you are connected again. So it's really cool for being mobile and being out there. GeoSuite's solution is it offers a single source of truth so that you can interoperate with other mining software, like I mentioned, various stages of exploration and mining, maintaining your data integrity. This is typically what an operation looks like that has reached gem maturity, and we help our customers reach this level of maturity in the geological information management. So all the way from your drill holes to reporting, we've got you covered. And at the top, you can see who's involved. Everyone's got, well, I won't say everyone's got access, but you can access your data. And I'll leave you with this. Rex Sanders said, if the data you need exists, if you found the data you need, if you understand the data you found, if you trust the data you understand, if you can use the data you trust, someone did a good job of data management. And that's your business asset right there. So give us a follow on LinkedIn, follow us on, sign up for our monthly newsletter.
Okay, Tanya, thank you so much. And thanks to Geological Society of South Africa for the kind invitation, and to Shego, who's been communicating with me on a continuous basis. It's my pleasure to be here. So, I'm going to be talking on the Geological Society of Africa. It's an Afro-global geoscience bridge between academia and industry. And the Geological Society of Africa, who are we? Let me just get this clear. Well, what's happening? Since it's ending, let's stop the video. Sorry, I'm just trying to get, okay. So who we are a Pan-African Geoscience Society that was established in 1973, and we have membership that cuts across the world, Africa, Europe, America, Oceania, and other parts of the world. And what do we really have as our objective is to promote the advancement of geological sciences in Africa, or art sciences generally, and by encouraging and supporting geoscience research, professionalism, education, training. And also we encourage establishment of national societies in different countries. And we also seek to promote sustainable and environmentally sensitive development of the mineral, water, and hydrocarbon resources of the continent. And essentially, we seek to facilitate communication and cooperation amongst different professional groups and among members and also other relevant organizations. And we really cherish this intra-society, intra-organizational cooperation a lot. And I think we have some going now with the Geological Society of South Africa, which we hope will be taken onto a higher level. So we also serve as a channel for the expression of views of African geoscientists, and report, investigate matters that are of general interest to them. Most essentially, we encourage the highest standards of professional competence and ethical conduct and the practice of geosciences in Africa. And one of our also important task that we seek to do continuously from now is to seek the preservation of important geological sites in Africa, geosites, where we publish a regular newsletter that is very consistent. And we also encourage and sponsor publications of the other African geoscience or other topics of geoscientific interests in Africa. And of course, we're the owners and publishing in partnership with Elsevier, the Journal of the African Art Sciences, African Sciences, that of course is one of the flagship journals on the African geosciences. We have a secretariat based in Ethiopia. We were generously given a building in the Geology Department of the Faculty of Natural Sciences at Addis Ababa University that we've been using as a secretariat to reach out in the world. And this, we also have a council that is voluntarily, the members voluntarily allow their time, use their extra time and energy to serve Africa. So our membership, close to about 2,000 now. This has been updated. Sorry, this is not really the latest. In 82 countries worldwide, that's where we have our membership. And then we have live members. The last figure is close to 200 now since our last colloquium in July. And ordinary members also more than 1,000. So we have 18 institutional members, and we have all of them connected by, most of them connected by emails and phone numbers. So this is the evolution of a number of members since 2000. We've been seeing some increase in membership volume from 2000 to about 2020. So it's been increasing. And then this is the membership by region in Africa, membership by African country. So of course, most our membership is still in Africa. We have about 13% of our members from Europe, about 3% from Asia, and about almost 2% now from North America, 0.5% from South America, and 1% from Oceania. And we could see this one, the graph showing the membership by other countries. So what are the benefits? Geosciences activities on the continent. We seek to have research funding. We try to attract research funding for our members, especially the early career geoscientists, try and look for scholarship possibilities for them. We try to disseminate information on national, regional, and international scientific cooperation with partners. And members are able to attend our conferences and colloquium at a reduced price. And of course, the publication of the Journal of African Art Sciences, which is a global journal with some appreciably high impact factor, helps our young geologists and old and young geoscientists, experienced experts to be able to publish their new findings. And of course, we also have our flagship conference, the Colloquium of African Geology, where since 1964, we have started this, and then it was in one of those colloquia that we had the famous, now widely accepted concept of the Pan-African magmatism. And so the Colloquium of African Geology offers a forum in which all geoscientists in Africa, or those working on African continent, come with their latest results, innovations, and we look at the issues of even nomenclature. We look at different concepts of geological evolution, and members are able to express their scientific opinion. We always call it the Olympics of African geology, where we have different opinions and scientific innovations being expressed. So these are membership dues, developed countries for developing countries. It will be graduated. So for life membership is about €150 for developing countries of Africa and some in Asia. For developed countries, €300. So I mentioned the Colloquium of African Geology. We started with Tom Clifford in 1964, and we had this beautiful evolution of the Pan-African magmatism and all that. And so we've had colloquia in different countries. We had 11 CAGs, that's Colloquium of African Geology, convened between 1965 and 1983. And it's been alternating between Europe and Africa, in London, Tuvalu, Sheffield, Leicester, Florence, Leeds, and all that. And each of these colloquium had a particular theme. And that's the tradition that is still maintained now. But since about 1987, we've been having 1983, we've been having it also more in Africa. So Swaziland was the first to organize one, very successful in 1993 at Mbane. And then we have had, many African countries hosting. CAG 19 was held in Morocco, in CAG 20 in New Orleans, in Mozambique 2006, Tunisia 2008, and on and on. And then Morocco was supposed to have held in September 2020, but because of COVID, so it was now held July this year. It was an online event that attracted over 400 participants, 179 presentations from about 38 countries. And it was an online event for three good days. The 28th Colloquium African Geology is going to take place in Namibia, and I believe that should excite our colleagues in South Africa in September 2023. I think the dates have been on. We will get out the information out soon and post it. So it's going to be September 2023 and in Windhoek in Namibia. So what are the initiatives we're involved in now? We're through UNESCO, we're having this African Network of Earth Science Institution programs. And then we have sundry collaborations with the African Union Commission. We are collaborating with the Organization of African Geological Societies Surveys and the Eurogeo surveys of the European Union in the Pan-Afro-Geo program. This Pan-Afro-Geo program is a program that's a continuous training program for geological surveys, officers, and staff all over Africa, and it's been done with a Eurogeo service. We're on the board of that, and we're one of those who have been planning the highly successful Pan-Afro. They finished the first phase. The second phase is on now, and maybe until another 2 years. So staff of geological survey have been trained in different aspects of geological sciences, field mapping, geochemical exploration, artisanal mining, and all of that. And then also we are very much involved, like many of you may have been aware, the development of the UNFC AMREC PAC standards in conjunction with the expert group of the African Union, which we're very prominent in, the AMREC and the Pan-African Reserve and Resource Code, development of which had got the approval of the African Union, kind of a comprehensive system for the sustainable management of all mineral energy resources of Africa. We can see Africa is so much well endowed. Mineral resources that we have seen many also presentations in this meeting. And but we believe one of the major issues we have in Africa, maybe apart from South Africa, where the I think Samval and Samrek is really doing a lot of good things, but that's not spread through the other parts of Africa. One of the major problems we have is the resource management in Africa. And so no country in Africa, apart from South Africa, which I mentioned, has a comprehensive mineral and energy management system and a code for reporting mineral and energy resources to stock exchanges and financial institutions, of course. We can see that this is a CRISCO, which some of us also are part of. And we can see that maybe it's only for South Africa, through SAMREC, all the other parts of Africa, blank. So we're part of this program in fulfilling the African mining vision, and the main principles of course, the African mining vision, which we know, the knowledge-driven, good governance, diversification, economic linkages, optimization, competitiveness. And it's also embedded with the AMREC one, which is the principles. We have the generic specification, environmental, social guidelines, competent persons guidelines, best practices, partnership, and then the PRC reporting, science specification, reserve and resource definition, specific project guidance, and competent persons requirements, and all. So it's all encompassing within the African mining vision. So the Geological Society of Africa is championing this with the technical and expert working group of the African Union. And then good enough now, there is now the African Mineral Development Center, which now has taken the responsibility of midwifing this AMREC park. Currently, they are in Ethiopia. I believe they are supposed to have their headquarters in Guinea-Conakry, but because of the political situation there, they are still temporarily headquartered in Addis Ababa. And I think the United Nations Development Program is having a lot of support, lending a lot of support to this. So we hope to see it rolled out in the nearest future, with all the structure still being put into place. So we hope to see that this AMREC rolls out, and then with essential harmonizing 5 critical areas. That is, the policy framework must be aligned to the SDGs and the ENV, to have a good resource management system, have economic capital allocation, business projects, develop new models, and also operational capability. At the end of the day, we are aiming for a holistic value chain and industry life cycle management, from exploration to even recycling. Now, this takes also cognizance of the fact that we had many standards globally, and we learn from them. It's not going to be, the quality of standard is not reduced at all. As a matter of fact, it's enhanced. And one of the things also is to see that we don't have these illicit funding, illicit fund transfers that we've been having coming out of Africa. Statistics shows that many of the funds that come into Africa are also illicitly, one way or the other, transferred out of Africa. So we believe with initiatives like this, we will be able to develop capacity in Africa. We'll be able to have a focus of African management system of the resources, and at the same time be able to utilize the funding in a transparent manner for the resource development of the African continent. So it's we also see the path AMREC, just like I've mentioned. So finally, it's to build a globally recognized and respected professional workforce through a force multiplier effect that links business process, gender justice, and also capability, and ensure environmental responsibility, ensure social justice responsibility, and also enhance economic wealth for the African people, provide jobs, and at the same time build a globally accepted standards that even people from outside Africa, investors from outside Africa, will also have more confidence also in investing in Africa. So these are some of the initiatives that we're involved in training, in research, in professionalism, and also in mining governance. So these are a great son of Africa, former United Nations Secretary General Kofi Annan. One would believe that they're far from being, Africa far from being hostage to an incurable resource cause. This generation of political leaders or political professionals, all of us, we have an opportunity to harness resource wealth for transformation in human development. And the Geological Society of Africa is at the vanguard of this, to see that globally and in Africa, our resources, our capacity, the human development, especially in the area of the earth sciences, are utilized for the purpose of enhancing the human development. Thank you very much. I appreciate you.
Thank you very much, Benga. We've got a couple of minutes. Does anybody have any questions for Benga?
Craig Smith here.
Craig, go ahead.
Where is the GSAF currently headquartered, or is it completely online?
Oh, I mentioned it. Said we are currently in Ethiopia, the geological building of the Addis Ababa University, and now that's the administrative headquarters. However, we also have, I'm president of the Geological Society of Africa, so we also maintain another office in Ibadan in Nigeria. That's at the University of Ibadan. So the functional one, both in Ethiopia and Ibadan. But our contacts are clear. We publish a regular newsletter. We have a website. Sorry, I don't think I brought out the website. And you can relate with us on our websites. You can relate with us on our newsletters and through all the channels.
Hi,
So you can just Google Geological Society of Africa. The website will come out, and then you can contact us directly. And we have vice presidents for each of these, for each of the regions in Africa. Vladi Alterman was a vice president for South Africa, and then the last election we did is Anna Ngulo, who is of the Geological Society of Namibia. And of course, they are going to host, like I said, the next card. We also have councillors and a vice president for different regions in Africa, West Africa, North Africa, and East Africa. So that's how we are organized on regional basis in Africa. And then we also have national officers for the different countries, national liaison officers. Currently, our newsletter editor, which I think the Geological Society of South Africa has been related with, I've got some correspondences from Tanya and I think Shego, I hope I'm correct, about collaborations in terms of information dissemination. And we are very serious about that. We want to collaborate a lot with them, and all informations, we can have a mutual flow of information amongst the two groups, which have started. I think Dr. Tama, who is our newsletter editor, is already working on this seriously with Tanya and Shego. I hope I'm correct, Tanya?
Yes, that's 100% correct.
Thank you.
Aurelian, you had a question for Benga?
Yes, thank you. Well, you kind of answer. I was thinking about West Africa, where we lack skills, and you are, as you rightly mentioned, are the only ones training people from South Africa. I know there's a big language barrier, but because we do speak, people, most of them speak French. But how do you think about expanding in this region, which is again completely deserted by skill, and nobody else will do it apart from you?
Yeah. Thank you very much. I think there was a presentation I made to, I think, what's this? A global professional groups, standards group. Taya, please, what's the name of this new group? I'm sorry that we that I sent our
Global Geoscience Professionalism Group.
Yeah. We did in the Geological Society of Africa, we did a study on the discrepancies in terms of capacity, availability, capacity development, and also resources in different African countries. And the results are very interesting. And these are some of the areas in which we're now trying to look at. And then we believe that trying to do this individually within the different countries may really not bring us the result. That's why we're using the AMREC, the African Minerals Management System, and the Pan-African Resource and Reserve Code as an umbrella, which has now been embraced by the African Union. They've got some funding. They've got some funding with the African Mineral Development Center now from UNDP, and I think they are rolling out. They've just started, I think, about 3 or so months, so just about July, and they have very robust program, especially with the GIMIS. They call it GIMIS, Geoscience and Minerals system, which they also have a major unit in the AMDC to take care of real capacity development amongst the geological survey, amongst the institutions and also professional associations in Africa for training. So the park, as the Pan-African Reserve and Resource Code, has an arm for training and capacity development, especially in the area of enhancement of competent persons, competent and how would I call the other one? We call it competent and
qualified experts.
Yeah, qualified. Thank you very much, Tanya. And qualified professionals. I think that's where we have the issue, and that is being tackled. We hope to roll it out, and then we also believe that many of you will be able to cooperate because you're going to be involved in training. I've tried to involve the, sorry, Tanya, I keep mentioning you, maybe because we are the closest here professionally, the two of us. I've involved there in some training last year with some young people in the Geological Survey and outside. And this is one of the things that we want to do in the Geological Society of Africa. Training is very important. Capacity development is very important. We cannot talk about Africa either controlling or having access to resources without really the capacity and the skills. And this is an area that we're so passionate about in Geological Society of Africa.
Okay, thank you. Good morning, everyone. I'm Toby from SACNASP. I'm the Professional Development Coordinator at SACNASP. So I work with a lot of programs with our candidates and our young scientists that have joined. But today I'll actually just speak about the registration at SACNASP itself, the process, and why we encourage young scientists to become part of SACNASP. So we are a statutory body under the Natural Scientific Professions Act number 27 of 2003, which requires all natural practicing scientists in South Africa to be registered. We are an organization or a council of scientists for scientists, and we have about 46 voluntary associations that we work in tandem with, such as the GSSA. So this is for us one of the most important relationships that we have with our stakeholders, because these are professional societies that are directly linked or directly involved with the scientists that register with us. They give guidance and input to SACNASP on a regular basis, and they play a crucial role in our candidate mentorship program. So that's the program we have where we mentor young scientists that are coming into the field, so such as young geologists from university who now have employment. We pair them with experienced scientists and give them curated courses in their field of work in order for them to actually develop into competent professionals later on. So involvement with the voluntary associations, such as the GSSA for geologists, excuse the sirens outside, it is a way for scientists to have a say directly with SACNASP. So you do that through your voluntary associations. Registering with SACNASP is quite important because for peer recognition of your experience and training, and of course the candidate mentorship program that I just spoke about, as well as once you become experienced, the CPD program or the continuing professional development program. So it's an important way of scientists to keep abreast with the new skills and developments in their field, as well as any training that they feel that they might require to be better at their jobs or their professional lives. There's numerous opportunities for networking. Of course, there's a code of conduct that we regulate. Register in 3 categories, the highest being the professional natural scientist. So these are scientists who already have work experience and have at least an NQF level 8 qualification, such as an honors degree or higher. Just below that, we've got the certificated natural scientist. So this is for level 7 qualifications or level 6 qualifications. And of course, the candidate natural scientist. So when you're fresh from university and just starting your journey as a scientist, this is the category where you would actually start. There's numerous fields that include geology and earth science. So the field that you register in is really dependent on your skills. What did you study at school? And as well as where are you working now? What is your job? So if you're working as a geologist with a geology degree, you would go that route. If you are working in environmental science, you go the route if you have the qualification for it. There's another And this is the recognition of prior learning. So this happens when individuals or scientists don't have sufficient formal qualifications to actually register, but they have extensive relevant work experience. So this is full-time work experience, not part-time. And in the case where they want to be professional without having an NQF level 8 qualification, some of the work experience has got to be in a position of responsibility. So yeah. Application is quite simple. Everything's online now at www.sacnasp.org.za and simply click apply now, and it will take you through the simplified process. Once you're registered, this then becomes your starting point or your pathway to becoming a competent professional. And for SACNASP, the key attributes that make up a competent professional is the professional who has the appropriate training at the right level. So as I said, if you are going for professional natural scientist, you need to have level 8, NQF level 8 or higher, or you can go the RPL route. You need to have adequate and relevant work experience as well. So if you're an honors degree, you need to have 3 years of experience, master's degree, 2 years of experience, PhD, 1 year work experience. You have well-developed communication skills, strategic and management skills, ethical behavior and awareness of legislation, and high attention to detail. All of these skills can actually be strengthened or developed through our CPD program, or the Continuing Professional Development program, which we launched in 2017. It's a very important program for us. In order to be able to maintain your registration, you would need to accumulate 25 points over a 5-year period. So this amounts to about 5 points per year that you can gain through a number of activities, such as conferences or belonging to a voluntary association. But that's why I mentioned earlier that being part of a voluntary association, if you're a geologist, being part of the GSSA is quite an important thing for you to be able to comply with some of the requirements of SACNASP, and for you to be able to fully engage with the CPD program. It would help you because they have a whole bunch of curated events that are accredited by SACNASP that will help you maintain your registration. We have recently as well launched a program for students that who are still at university, so a student enrollment program. It's quite important because it then sort of is almost like a crash course into SACNASP and everything that SACNASP is about and everything that SACNASP does and what you will be required of you once you are fully registered. So it's a program that is ongoing. We continually go out to universities to speak to students, and we will, I'm sure, when the new year starts as well. But that is all from my side and the SACNASP talk. Thank you.
Thank you, Tanya, and thank you very much for inviting me. As I said, you led my question. There's a lot to do in Africa, and there's unfortunately not enough skill sets in Africa to tackle the growth of what we need for the future. But that's a side comment to what I'm going to present today. So don't hesitate if you have any questions. I think we'll do that at the end. But it's a presentation that I've changed a little bit. So obviously we are a public listed company, so we have to read the disclaimer. I'll leave that to you. We have to do it, unfortunately. So where we are, so we are in West Africa. As you can see here, it's Mali and Guinea. So we have 2 assets, one to the southwest of Bamako, and the other one in Guinea. Actually, Bamako is our center of operation for our mine. We've been in production, believe it or not, for more than 5 years. Not many people do know that, but we have been producing, as you can see on the chart. I'm not sure if you can see my laser or something. Let me just try to bring this up. We've been in operation since 2017, and what we did is we in 2020 we paid our first dividend. So for a junior mining company, people were quite surprised to see money coming back, especially when you look at our exploration property and the size of them, which are quite important. Usually junior mining companies tend to reinvest in exploration, but we had a different view at the time. So where we are, I mean, I'm sure you're all familiar with West Africa, but just to highlight, I mean, why and who are the players in our country. These are two very different countries in terms of maturity, but we feel like Guinea is a great place to explore. I think a few people said that if there's a tier 1 gold asset to be found, it'll be in Guinea, and as you can see on those numbers, there's very few exploration spending done in Guinea, despite the fact that we have some big players there and a great success story, exploration story, which is Predictive Discovery, the Australian company, which is next door to us, as you can see. So the executive team, most of the team have been working together for 25, 30 years on various businesses. We have the chance to have a strong backer, which is in the name of George Cohen, with his family, who owns a significant stake in the company and provided most of the capital to bring into production and to support the company and have the long-term view that you need to have when you explore in Africa. I'm sure you'll all agree. So that's really quickly, is a French entrepreneur who's been doing lots of different businesses, but he was very successful. As you can see, his main success was multiplying his money by 28 times during the 2001-2002 IT, let's say, a bubble. He did again the same thing, distributing gas and selling to Eni, and the same thing, power and selling to Volvo. So very different businesses. They're coming from outside the mining space, but they have, and I'm part of the team now, a very strong mandate to acquire a company, structure them, and grow them, which is exactly what mining is about. So roughly, we traded in the TSX, as I say, TSXV, and you can see here our share price. You can all Google and see what's performance. So I'm not going to talk too much about that. There's some key dates. Obviously, the first dividend we paid to shareholders, and recently the acquisition of the project in Guinea that we're just finalizing. And as you can see here, the shareholder structure, sterling structure, which is owned by two big strategic investors, which are supporting the growth of our company, have supported this company to grow. Values, it's very important these days. And I think for us, it was a core value when we started the business. There's no way we can operate without the full support of local community. And by that, we tried to reduce over the past 5 years the number of expats. So as you can see here, we have 44 Malian manager. We have only 7 expats rotating on site for our mine in Mali. It's a small operation, but we're trying to lower the number of expatriates, bring up the skill set locally, and most of them are coming from Africa, the region, if we can, and if not, we try to tap into the talent pool in West Africa, and if not, we go all the way to South Africa to find talents. Obviously, we abide to most of the code of conduct that there is in Mali and apply around the world, and try to do our best to operate safely, which, as you know, safety is one of the big challenges in the region we are. So something that we do not take lightly, between the personal security, the transport, but also obviously gold transport. A big subject for us is the renewable energy. We've brought online one of the first solar PV plants in Mali, which currently is supplying 30% of our energy, and we'll do the same in Guinea. We've just signed a partnership with Vivo Energy to provide up to 50% of our power consumption through solar. It will be the first PV plant in Guinea. So again, very, very proud of that. They're going to be investing to take care of everything, the thermal, the PV, and everything. So we're very lucky to have them. And again, the values is not just to make it pretty on a PowerPoint presentation. We do think it's the only way forward for mining industry to have the license to operate. So we try to take most of the international recognized let's say, regulatory body apply to Mali, but also we try to make everything we can locally. And as you can see, we push for local content. So we've spent 17 million in 2020 in the local economy. I mean, in our region, we're not talking in Mali, we're talking in our sub-region of Mali. And we're going to increase it to, we have increased it to 21, and it's going to continue to grow, which is something very important. The keywords in numbers, 38% of the managers of Mali, 31 are from the Sikasso region, as I said. Something we've developed over the years is the mine school concept, where even the minister coined this phrase. So we do our best train and upskill people so they feel like they can be proud of our small operation. So I'm going to go through quickly the operation. I know it's a bit less of a focus for this crowd. It's still important because it pays most of the bills for the geos to explore. We are located just between Morilla, which you might have the sad news that they're now closing down, and Siama. So operation, we treat about 2.5 million ton of product. Our resource are, some say, quite small and low grade. You might see some of the grades here, and I've been in South Africa for quite a bit. There's a lot more grade in South Africa than there is in Mali, but we tried to make it work, and we made it work, as I showed on the financials previously. So our resource is at 0.74, and the only way we make this work is mines. We've been in operation since 17, as I said. We've been producing between 40 to 50,000 ounces throughout. So obviously we face the challenge of rising costs, which is also a big problem for people operating and exploring in West Africa. Some of the numbers, some of this are from the corporate presentation. So I'm happy to take any questions, but like a Swiss clockwork for 4 or 5 years, you can see the recovery and availability of the plant, despite a very low grade. We're trying to do our best to make it work, despite the year 19, 20, 21, the year of operating cost. We took this land package from Newmont a while back. It's a very old resource. It's been discovered in the 90s, so we have a pretty big land package around the mine. Obviously, it's a long strike. We've been doing quite a bit of drilling and trying to expand the ore body. We know it's probably sealed to the west and to the east, but it might extend throughout this direction. We starting, and all this work that you can see here on the map is part of the new work we've been doing with our team recently this year. I'll be relooking at the 2005 regional geological interpretation and trying to see what is the potential for our operation in Mali, whether we can expand the life of mine. So this is all we've done, and it's quite. It takes some time. Not everybody realizes the amount of work that goes into these interpretation, but that needs to happen before we can start drilling again. So we're very busy trying to see south of it whether there's something to continue. We have a few exploration properties as well that we are exploring. So to the west, Mali in the Senegal and Mali shear zone, which, as you know, is very prospective for gold. For now, it's less of a priority. We had some good intercepts, as you can see on the pictures, which is also another problem in West Africa. It's been already mined, already free mining, I would say, on our property. There's some incredible grade. We had 3 meters at 101 gram a ton, but obviously it's narrow vein and it needs a lot more drilling to work out if there's something on this property. The other big growth for our company, it's Guinea, which, as I said at the beginning, we feel is very unexplored part of West Africa, and despite being next to the Senegal and Mali shear zone, with the same structure that we find all the big mines that we have currently today in Mali. So this is the size of our property to scale, which has always amazed me, the size compared to the country. So it's not a new. Wow, we have special effects here. It's not a new property, as you can see here. We're really talking about a a restart story. Some of these you'll see some of them was mine. You might recognize some of the names. The BLGM obviously was there in Guinea. There was a first feasibility study in 94. And then it was acquired by Semaphore. It was drilled, put in production, put in care and maintenance, and acquired by the team that now we bought it from recently. So it's a very long history, which the problem with changing hands so many times, you usually end up with these pictures. I know the geos that work for me hates that I present this picture, but like a kind of a core shed completely demolished. So there was quite a lot of work to do to work out which core goes where and what how it's been assayed, how it's been cut. So a lot of work. You can see to the right, obviously, this is some of the new drilling, but we've been also relogging some of the ore cores. There's about 500,000 meters of cores that have been stored and sitting idle in the jungle for a couple of years. So a lot of work from the geological team that we have now on board that have done the bit of the shallow comps work to piece everything together. Obviously, we had to refurbish everything. That's the camp, the before and after pictures. That's the site that we acquired. And as I said, there was an enormous amount of work, and most of the work, probably more than half of the budget, was actually not new drilling. It was just trying to sort out original logs, check the colors, do the twinning, resurveying the holes to make sure they some of the downhole survey, and making sure we can rely on the data. So and really an enormous amount of work, because the idea was obviously to publish to the highest standards possible, which is what we did with the 43-101 that we released recently. So what we end up with, this is our property I showed you previously in Guinea. This is all our exploitation license, and this is the mine. I'm not sure if you can see my pointer, but I'll see if you can do this. Oh yeah. So this is where the mine is. This is where they were mining, and this is our exploitation property. So everything we can find here, there's a strong incentive, obviously, we'll be able to mine it and to process it. You can see to our left, there's predictive discovery, the resource here. There's Kurusa starting up, and then there's resolute mining to the next to us as well. So in this basin, there's been 8.5 million ounces discovered in the past 4 or 5 years. So it's a very prospective basin, and a lot of work has been done over the years. You can see here drill holes, trenches on all those zones, and some of them are too far away from the plant. There was an underground mine up here. We have a Lycopodium, a 1980 studies for underground workings around here. And obviously the pits that have been mined for 10 years that we have to reopen and re-entry. So it's a very prospective area. And it's not your usual greenfield exploration. It's literally there's too much information. It's a data-rich environment, so which is a completely different job. We end up with a big infrastructure. As I said, this is coming from our PFS, but a lot of existing pits, as you can see here in yellow, and lots of small pits. So this is what we face in our part of the world. It's the egg box design, where we have lots of small pits that we have to mine sequentially, and obviously try to minimize the cost and the transportation, which is also a bit of a big challenge for us. Obviously, it's a fully equipped site. I showed you the canteen and the camp. We can host 250 people. There's already 150 people on site. We have an airstrip, a road, everything's there. That's the beauty of having an old operating site. So we're really happy about that. And this is what we got after the drilling and reinterpretation. So we've got 800,000 ounces of reserve, 1.2 of MNI, and 1.4 of inferred. And that's just a cross section of what we're looking for. As you know, as I said at the beginning, Guinea is in the early stage in terms of country for gold exploration, not like Ghana when they've been underground already. So we're looking for easy at surface oxides. So you can see here the lithology. mainly sap rock, and then we'll go deeper. Our plant can treat 50/50, so we'll exploring according to our plant specifications to make sure we increase the resource and the reserve straight away. So this is some of the key numbers, economic numbers of our PFS for the project. As I said already, 2.7 million ounces, $150 million capex, 110,000 ounces per annum, 1.34 gram on average, and 6.5 life of mine. We're talking about a $200 million project NPV. Some of the operation number, I mean, all that is public on CDAR, obviously, and on our website. So I'm not going to walk through all the numbers. Some of the challenges we will be facing is obviously the strip ratio, 4.4, which is quite high. I mean, it's always too high, I would say, but this one will be a challenge. So we'll have to really take in consideration the mining services and the mining providers in Guinea and what they can provide, because we want absolutely to aim for a below 1,000 all-in sustaining cash cost, because that's the target we've set as a management team. This will change. I mean, you've seen the size of the property. We're talking about 400 kilometers square of exploitation property in the highly prospective basins with known mineralization and resources in some cases. That's been done previously, but historical resources. So we're very confident that this will increase at the back end. The plant obviously will already be built, so we have opportunities to increase life of mine. Very good recovery. Obviously, this site has produced 500,000 ounces of gold already. So we have all the numbers for recoveries. We have the mining sequence bench by bench. We have the grade control data. So we've reconciled all the operational data with the exploration data at the time, with our new exploration data, with everything we can gather on the properties to make sure we can rely on them. So again, an enormous work in terms of exploration, you can say exploration, but not in terms of not drilling, but exploration of data, and then resource modeling, which is still key for us. Yeah, some of the details. Obviously, while we progress those numbers will firm up, but that's what we're looking at right now. We want to be in production first pour in Q1 2024. So we really have to get going, and this is what we're looking at. So it's a relatively small plant, but we feel like we can put that into production with a 95 million capex. Obviously, you don't go alone in those countries. We rely on strong subcontractors that have been with us for more than 10 years. So we feel very comfortable, especially in the construction and EPC side. And obviously another big challenge, and we do the same strategy we had in Mali, in Guinea, is that you want to work with local suppliers as well. Some of them have a local international reputation, but from the country. So there's lots of Guinean company that will be involved in this project. We feel we're in the right box. You can see here different projects with capex intensity and size. We're not too big, but not too small either. 100,000 ounces a year, and some of them get built at the moment. We said the Tieto mining, so the Abuja project in Côte d'Ivoire, or the Kouroussa project, literally 2 hours drive from us. So we feel we're in the right box that are doable to bring into production. So that's roughly the timeline we're looking at. Resource drilling, we've been doing it extensive resource drilling this year, updating the resource. You can see here the PFS that was done in Q3, and then we're moving into we've already ordered long dig items. So we've already purchased the SAG mill, we purchased the plant equipment, and a few starting to do a few civils. So we feel very comfortable to take FID before the end of the year. Obviously, after finalizing the financing package with banks, so we are currently in the process of doing that here, and hoping to get this sorted out before the end of the year, so we can draw down on the money when we have our DFS. So one question you might ask is, why doing DFS after construction decision, which is a fair point. But we since there was a DFS done previously on the project's been in operation for 10 years. We have all the data, and the site is already ready to go, safe for dewatering. So we feel like with our experience in Mali, which is somewhat similar to what there is in Guinea in terms of culture and local network and local network of companies that you work with, we feel we can start early prep work of construction before having a DFS, which will come in Q2 of next year. So with the first pour, I said in Q1 2024. So that's all for me. Some of the slides I went through them very quickly, but I'm happy to take any questions on what we do. My entire team are South African geologists, but I'm not. So please not too technical, but I'm happy to answer any questions you may have.
Thank you very much, Aurelian. That was an interesting look at what you guys are doing in West Africa.
Thank you.
Any questions for Aurelian? Benga, I see you have unmuted yourself.
Yes. Yeah, thank you, Aurelian. Thank you for the great job you're doing. It's interesting to know that the deposit is low grade, and that's it's encouraging because people are looking at low grade ores and are thinking maybe it may not be commercially viable, especially when I look at 0.2, 0.3 gram per ton, and I can see that at least we have some good economic differentials that encourages some investment in that area. But my question is, what's the cost of your production per ounce? Let's say gold is selling maybe for about 1,700 ounces. I mean, dollars per ounce now. So what's the production in terms of processing, especially when you're dealing with the cratonic gold? As you can see, this is purely beryllium. Yep.
Yeah, exactly. I think we could be a textbook for beryllium ore. So there, we our all-in cost for the first half of the year is 1,500 Canadian. So now Canadian is going up and down, but it's probably 1,200 or something, 1,200 or 1,100. But you're right about the low grade, and everybody when we started said we were crazy and we'll never make it, which we almost didn't make it. But it takes a very different approach to management and mining companies, and even more geology. Because we manually doing a grade control every single benches, because you can't miss grade, right? Because we low grade you make money when we have a 5% difference, but with all the uncertainty you've got from your sampling to your results to your 5% is not much. So for us, we need to be the management team and the geos 100% coordinated to make this work. And it's hard work. I can tell you it's hard work.
I can imagine. Well done.
Thank you.
Hi, Tanya. It's Wilson speaking.
Hi, yes, Wilson, go ahead.
Hi, Aurelian. Thanks for the nice presentation. We actually have a more similar project in terms of grade, and it's quite actually encouraging to see that the grades that you have can actually end up being able to open a mine. But tell me, maybe my first question would be, well, what's your cutoff grade actually? I didn't get that.
So in Mali, so the mines that have been operating for 4 years, our cutoff grade is 0.27.
And you're averaging 0.8 or so.
Our resource at 0.74. So it depends. We're averaging around 0.7, yeah. 0.6,
and with the current project, your NPV at?
So if you combine the two, so it's PFS. So we're comparing a producing asset and a PFS level stage. The PFS is 200 million US. The operating asset is making 20 million a year. roughly. So you're talking about 150 million, probably. So we're talking about 350 million, 400 million dollars of corporate NPV, roughly.
Just one last question. How in terms of the mining, what's your max depth that you'd go with those numbers?
In terms of mining, you mean?
Yeah, in terms of mining, where on surface, where do you start, and in terms of depth, and how deep would you go?
So in Mali, we stopped very low because we have a quite thick saprolite, so 40 meters. That's it. So the plant is not big enough to treat hard transition. So we try to scrap the top of the transition, but the lower transition will be hard to process. So we're looking at oxide. So we're not going to go deeper than that. Obviously, the horizon will change, and it's different throughout our property. But that's what we're looking at in Mali. For Guinea, it's 50-50, 50 sulfide, 50 oxides. So we probably go 65, 80 meters at the start and see how it goes. So because we still need to figure out how we can push the geotech and how deep we can go, which has a massive impact, as you know, on the strip where you go down. So that's what we're looking at. So we're still talking very shallow mining, open pit mining for now, compared to the rest of the world.
But so still with a plan of going to 65, 80 meters with a 0.7, 0.8 grams per ton, do you still think it's feasible?
So for Guinea, we have much higher grade, and the average grade is 1.34. So that's for Guinea. For Mali, no, we'll not go deeper than 40, 50 meters. That's what we have at the moment. It was the heart of the deposits, the center, which was higher grade and less patchy, and now it becomes a bit more challenging. So everything else will be above 40 meters in Guinea, in Mali, sorry, and in Guinea, it's totally. We start on transition. The first grade we've got on transition when they stop is 3 grams. So for the first year, we're actually going to produce 150,000 ounces with the same plant. So our average weight going to go up. So that's what makes this work as well. So no, you wouldn't go to answer your point. You wouldn't go 0.7 gram at that depth. That's crazy.
Brilliant. It'll be nice to catch up with you, to have a talk after maybe this or at some point. I'm quite interested because I'm working on a similar project in South Africa, a little bit grades not too far from those. And it would be nice to learn from what you guys are doing out there.
Absolutely, that's why I'm here.
Great stuff, man. Super.
Thanks.
Cheers.
Thanks
everyone.
Thank you. Any questions from anybody else? Just to note, I can imagine the amount of work it was to convert your core sheds from what they were to what they are now. I had a similar core shed when I was working in Côte d'Ivoire, so I feel your pain entirely.
Yeah, but we have a great team. Luckily, but it takes time. For sure.
Right, so for those of you that don't know TECT, we're a group of applied structural, if you want, half an economic geologists. We're about 10 of us in the office at the moment. We apply geology for geotechnical analysis, hydrogeology analysis, and MRE estimation. We don't do MRE work ourselves. We partner with Ken Lomberg at Pivot, or Howard Baker in Cardiff, who's an ex-SRK guy. So our speciality is mapping, structural analysis, and construction of fully constrained implicit 3D geomodels for lithologies, major structures, and joint domains. And pretty much all of the open cast mines in SADC are running on our models. So we're quite happy with that. And we've built long-standing relationships with our clients. All of the geos in the office, extensive field-based experience in structural and economic geology, and we all know how to handle ourselves when it comes to leapfrog and micromine. We've been going for 22 years. As I said, we built long-term partnerships. And we also subcontract a lot to some of the bigger consulting companies, the SRKs, so 9 years old, WAI, Hatch, etc. So we're very often asked to build models for them or to help them with their structural interpretation of the geophysical data, which we very gladly do. So we work as part of bigger teams as well. This is a team. The top sort of 2.5 lines or 1.5 lines are sort of permanent staff. We have an associate called Brett Davis, who used to be part of Allfind, working with Jun Cowan. Prof. Alex Kisters, structural biologist and head of department at Stellies. And recently, Paul Macy has joined us as an associate as well. He used to work for the CGS for about 23 years. And he's going to be setting up a mapping course for us and rolling that out. And then we also have Damien Smith, Bushveldt, a complex geologist. Howard, as I mentioned. Peter Cruz, he's just finishing his PhD at James Cook. And then Dr. Jody Miller, also from Stellenbosch. So very concentrated set of knowledge, very focused on structural geology. These are the commodities we address. These are the clients we've worked for. We're probably going on for about 200 clients now. And these are the areas that we've worked across the world. We're slowly stretching out to Canada, Greenland, Kazakhstan, Chile, and more recently Australia. You can look at all this on the website, it's all there. We also provide training courses, 3D geomodeling, that's the one I do. I also contribute to Leapfrog Masterclass, which is kind of a very high-level advanced masterclass for people who've had a year or two, maybe more in applied Leapfrog. We also do a structural geology course on data training and implementation, and we also do Paul's new course, Modern Geological Mapping. Almost done. We also find that publishing our work with our clients, the geoscientists that work for our clients, is really good for keeping the standards high and for improving the report writing. So our view is that if you're not at the level of a peer-reviewed paper, you're not quite there yet. So we find that writing reports really benefits from this initiative. So we're always encouraging people to publish. We also have initiatives, what we call initiatives. This is a Bushveld Complex compilation. This was published in Physics in 2019. It's basically a purchasable GIS project for people interested in exploring in the Bushveld. Anglo-American Group Discovery have already bought it. We're building one for the Lithuanian Arc at the moment. We also have 2 initiatives. Other initiatives, one is GeoPoint, which is an online spatial database that you can log into. It's through ArcMap, it's through Arc Server. And basically the idea is you click on an area and it tells you what data is available from the literature. It looks at georeferenced maps from articles, and it gives you a list of uplinks or DOIs that you can go off and then do your research. Very handy for us. We use it in-house to focus on an area. And the last one is GeoFlight. If you're mining these days and you want to be safe, you need to start adopting all of these other technologies, remote imaging, power walls, scanning, etc. So we have a small company that does that from within TECT, and that gives us access to parts of the pits that we couldn't otherwise get to. So that's TECT. In an overview, you can go to tectgeological.com for more information, and I'll leave it there.
Okay. Yeah, thanks for the introduction. Like you just heard, my name is Tom. I lead the exploration and geology side of Zamari Minerals. I'm going to try and run through our projects, but focus on one project in particular in Tambu, which is probably our most advanced project to date. Yeah, so here is our disclaimer and forward-looking statement. I think that everyone's probably seen enough of these today and in their lives to know what it's about, but it has to be there. So Zamari Minerals was established in 2018. We're UK based, focused entirely on Zambia. Currently have 4 projects, all focused on copper. They're across Zambia, so in the copper belt around the Pan-African granites, and a new license in the Western Foreland. We think that Zambia is a very good jurisdiction. It sort of strikes a balance between prospectivity and how much exploration and mining has been developed there. Recent changes in governance as well, right, with the election of HH, we think has improved the environment for exploration and mining investment. And we've seen investments come from groups like First Quantum already, thanks to improved tax situations. One thing that we think is important for Zamari is that all of our licenses are 100% owned by the company. So these licenses were acquired from vendors in country, but lessons learned from other junior explorers in Zambia shown that if you have a shared license, it can lead to problems further down the exploration timeline. So rather than have shared ownership over a license, what we've done is acquired licenses in 100% as Zamari, and had local vendors become significant shareholders in the company. This creates an alignment of our interests and will hopefully prevent any sort of issues in the future. This is our team, board and management. We have a varied background, but I think we cover all the bases between us very well and have very good synergy. Julian Hammond is chairman, comes from an oil and gas background. Roger Murphy, a geologist, but most of his experiences in mining finance in London. Tunde, a Nigerian non-executive director. Ian Isley is our sort of accountant, chief CFO, and myself over there. So these are our licenses. Like I said, we have four projects. Today I'm going to focus on Tambu, which is on the southeastern side of the Kapompo Dome. We're directly adjacent to the First Quantum mineral tenure that covers the Trident projects, Enterprise and Sentinel. There's the Domes region, the South Lamana and Kansanshi. Our other project, Dongwei in the south, is looking at IOCG style mineralization associated with Pan-African granites. Kaleni Hills is our newest acquisition in the far northwest of Zambia that is very early stage at the moment, but I think in a very interesting area. This is the Western Foreland on a basement edge, so analogous to things like Kamoa, hopefully. And then Marundi is right in the copper belt, looking at mineralization in the syncline that hosts Mufulira and Makambo on the northern side. So I'll focus on the Tambu. This is the setting, southeastern side of the Kapompo Dome. Like I said, adjacent to First Quantum, Enterprise, primarily nickel mine. I think the resource has changed now. It's been updated. I think it might be closer to 40 million tons. Sentinel, very big, but relatively low grade. Lamana in the Domes region as well. We're not too far from Kansanshi. And Arc Minerals, who have had recent success on the opposite side of the dome from us, with their agreement signed with Anglo American. They're still going through due diligence, but shows that there's a lot of potential in this area. And so when we acquired the license, the state of our knowledge, right, when we acquired the licenses, was essentially this map. And I'm going to try and run through sort of the story of the exploration that we've done here for. It's only really been two years, or even less. Well, just about 2 years now. But we've done of exploration here, so it's still sort of early-ish stage. But yeah, when we acquired the license, this is essentially what we knew. This map, I think, was generated as part of the work around Enterprise and Sentinel, right? So we knew that it covered part of the basement edge, the top lower own, and that it's a long strike, and it's the same basement edge that hosts Enterprise, and was sort of a long strike from Sentinel as well. On this map, there are different interpretations of how that fault that I call the Southern Graben fault that runs through the south side of Ntambu, how it continues, but it's the same orientation, I think, can be sort of traced in Sentinel. So we're a long strike from both of the deposits, and the main feature here is, of course, the Kalahari cover, which is shaded in yellow, and the acquisition of this license was based on this hope that we'd find a way to image through this cover and to explore this ground effectively. So, when we acquired it, we did some initial work trying to see what might be effective here. And so obviously we did some reconnaissance mapping and tried to map outcrops, which wasn't too successful. Those are points in white were just from sort of the first day in the field. We tried termite mound sampling, which is talked about a lot in Zambian exploration, but the results that we had from comparative samples taken from termite mounds and adjacent to them didn't show much, and I don't think were cause for encouragement. We spoke a lot to different consultants and providers of partial leaches, but also weren't convinced of its efficacy, at least not in this area. There was a hydrolithogeochemistry study done here as well, but we also thought that after discussing with a lot of people about hydrolithogeochemistry, that you really need an understanding of the subsurface to interpret the results effectively, and to do that you need to drill. That's sort of the wrong way around for us in exploration. And we also did a little bit of remote sensing, which I think helps. Vegetation is obviously an issue here. It helps a bit in defining a bit of the geology, but I don't think it's a huge improvement over the coarse geological map we have. So at this point we're a bit stuck, and we realized that we will have to focus on geophysics, right, to make this exploration program work. But luckily, First Quantum appeared sort of soon afterwards. We began speaking with them and saved us a lot of time and trouble, because we signed a technical cooperation agreement with First Quantum in 2021, and through that agreement we were provided with a whole data package that they had generated before. So First Quantum had held this license as an exploration license, part of the Trident project, and had explored it, but had to relinquish the license when they were developing the mines. So this was part of their relinquishment, and they gave us all of this data. The data includes airborne mags and radiometrics, as well as an airborne EM survey, complete geochem. There's over 2,000 points here, and 17 drill holes. There are 7 diamond drill holes, no, sorry, other way around, 10 diamond drill holes and 7 RC holes. Logs are available for all of them from First Quantum, but they were only partially analyzed. Not all of the cores available for review at the moment. So this is incredibly helpful to us. Some of the drilling had intersected a bit of mineralization. Sort of sniffs 1 meter at 0.6% copper. So that was encouraging, and we sort of had something to work from. A lot of people ask us why do we think that First Quantum are helping us? Because this technical cooperation agreement doesn't give First Quantum any back-in rights or any ownership or anything like that. There are no conditions attached to this. And we've asked First Quantum this question ourselves, and they've said this is enlightened self-interest. The development in this area, thanks to the Trident project, is all done by First Quantum. So any discovery or development that happens here will benefit them, even if that if there is a deposit here, even if it belongs to First Quantum or not. So now with this geophysical data, we realized that, right, we can make a significant improvement to the previous geological map that we'd been working in. Right? And we knew we had to do this because of the Kalahari cover. So we used an independent geophysicist, Klaus Knupp, who some of you might know from Namibia, who generated a new geological map based off of the geophysics that were available, as well as the drill hole data, right? And that drill hole data, you know, was the drilling was done after the geophysics. So any previous, I think the first interpretations that we had were based on just geophysics without drill hole data. So this is, right, a significant improvement. And then with that interpretation exercise also generated 6 preliminary geophysical targets that Klaus, you know, considered interesting enough for follow-up. You know, neither of these are properly tested with the drilling. Yeah, and we start, you know, here we started to think about, okay, 2 broad regions of interest for the license: the northern edge, where we're close to the basement edge, and then this southern Graben fault, right? And could that host something similar to Sentinel? You know, I mentioned that there is this low level. Well, there are some hints and sniffs of copper and nickel in some of the drill holes in the north. And that sort of made it a higher priority. I think any mineralization on the southern Graben fault was more of a conceptual target, and so we decided to essentially focus our efforts for now on the northern side of the license. So this is the low level enrichment that I spoke about in the drilling. This is looking. Sorry, I don't have a direction on that view, but we're looking towards the southwest, right, where holes 7 and 8 are, and this is further to the northeast where holes 4 and 5 are. These simple red outlines on the drill holes are just limits of, you know, copper or nickel enrichment that were analyzed in the drilling. Yeah, and so then First Quantum kindly let us look at the core as well, which is held at the Trident project, right? That seemed like the next obvious step to do after the geophysics. And the core is, right, the rocks here are difficult to interpret. There's right, so we can't do any field mapping because of Kalahari cover. There's a pretty high metamorphic grade, right? You have kyanite and garnet here. Right, alteration. A lot of the rocks are altered so that you can't really tell what the protolith is anymore. There's repetition of units. So positioning yourself in the stratigraphy here is quite hard. So looking at this, we realized that, okay, to have a foundation to, you know, work on as a mineralization model to explore, you know, we need to look at enterprise and base our work on what's known about enterprise. Right? And so a lot of make a lot of references to this work by Capstone from 2014 on enterprise. So enterprise is hosted within this Graben sequence. It's down thrown, all within the lower Rowan. You know, I think the faulting is relatively complicated, right? Because these normal faults have been interpreted since sedimentary, and they don't pass through the overlying upper Rowan. But then these transfer faults that occur perpendicular to those faults do cross-cut and are likely reactivated. And I think structure is, you know, probably more complicated than that. And to add to all of that, there are these low-angle detachments or shears at the base and at the top of the lower Rowan. And above the lower Rowan, there is also this polyolithic breccia, right, which is this paleokinetic breccia that's probably part, used to be upper Rowan. but it's been recognized across the Kapompo Dome. So that sort of becomes an interesting marker to look for, which hadn't been logged before in the historic drilling by First Quantum. So then we went back to the core and looked at it again, and well, we realized that essentially there were pretty thick intersections of this polylithic breccia, right? So top left here is an image from the same paper of the Enterprise polylithic breccia, and on the right here is this is whole core, so the picture isn't as good, but I think it's quite clear that it's the same unit, right? So this is polylithic breccia at the base, well, close to the base of hole NTO4, which is this one just over here. And then we identified that polylithic breccia also in hole 6, which is along strike. We're drawing a little pink line here, which suggests that the position of the polylithic breccia is lower beneath hole 7 and 8. We're looking in the same direction here as the previous image, so sort of southwest here and northeast on this side. And so the obvious and big implication of that is if that drilling is in polylithic breccia, was the lower Rhone intersected? And if the lower Rhone wasn't intersected, right, the target stratigraphy, at least, if we're looking at this from a perspective that, right, we're using the Enterprise model as a basis for exploration, that, right, the target stratigraphy hasn't been intersected. So, right, that's interesting, and also, it's worth mentioning that the comparisons, in the core of the polylithic breccia are really similar. Right, it has these, it's matrix hosted, diffuse edges, mixed clasts of geology. Those clasts have been known to be, over tens of meters thick, which I think probably led to misidentification before. So on the right in this core, you can see there's a thick intersection of this dark unit. I think that's a strongly altered mafic clast, right? But I think previous logging would have logged that as an altered mafic unit. It continues further up from what we can see here. So that's encouraging. We can see, or we can start saying, or thinking at least, that previous drilling hasn't tested the target stratigraphy. So then we compare, right, going back to the original map, the course map we had when we first started, well, before even the acquisition of this license, and compared it to our new geophysical reinterpretation. We also noticed that the low angle fault and the upper row and lower row contact is shifted, right, significantly to north in our new interpretation. So that corroborates the thinking, right, that the drilling, right, which is, you can see the drill direction on the black lines here, which is drilled towards the northwest, right, units broadly, we can sort of say are dipping to the southeast. Right, so we can sort of say, okay, well, the new geophysics corroborates our interpretation that we didn't intersect the correct stratigraphy. And so the copper sulfides that were intersected historically in hole 7 might just be sniffs of copper from elsewhere. And so then the next stage, how do we move on from this and confirm what we're thinking? We spoke with First Quantum on our quarterly meetings, and they had recommended we look at using AMT. We ran 3 test lines at the end of last year. The results were good, and that sort of gave us enough confidence to come back and do a much bigger AMT survey, which we completed this year. These are the results. This is line L710. This was actually collected last year, but it's quite nice. And was collected right along this drill fence. This is where there's that sniff of copper, which is why we did this line. Right, and so in these rocks, in these holes, we only have what I interpret now as upper Rhone carbonate. and there is a stratigraphic conductor beneath those. Does that represent the polyolithic breccia? I don't think so, because in other work, that polyolithic breccia has a pretty mottled sort of mag signature. And it is misting, it isn't always continuous, the breccia. So that might be a low Rowan stratigraphic conductor, right? And then I don't know whether that is worth drilling yet, right? But there is a break in that stratigraphic conductor that I've highlighted here. And if you trace that up, it does, it does align with that sniff of copper. And that sniff of copper isn't in a reductant, right? It's in a fracture within the metacarbonate. So that's not really the target mineralization we're looking for. We look back at the geophysical interpretations where that lower Rowan contact was mapped by the old mapping and the new mapping, and I don't think either of them match up here. So I think our sort of next stage of work is trying to reconcile, right, where the airborne geophysical data set that we have, the AMT geophysics that we have, with the drill hole data that we have to begin to build a better geological model and the structural model. The next line, L17 along, is, shows that actually the AMT sections, I think they work really well, but the stratigraphy isn't always as clear as the previous line. So here is where we have a thick intersection of polyolithic breccia. There is a sniff of nickel in there, which looks again like it's lying over the top of one of these faults beneath that polyolithic breccia. But the contact and the extent of that polyolithic breccia here isn't that clear. There is a good conductor there beneath that unit, which may represent a target. And what was interesting about that conductor was that we looked at this AMT data, and I haven't worked with AMT data that much before. Well, actually, I haven't worked with AMT data before at all. So we wanted some help with the interpretation, and again through First Quantum, we spoke to Gavin Self, who does have a lot of experience in interpreting AMT data. He looked at the sections for us quickly, identified several types of conductors, and one of the target areas that he drew and one of the conductors he picked up is that conductor off of the same line, L17. This is a different, on the left, it's the same line, but a different interpretation of a different model of the AMT data, but it identifies that conductor. And that's a linear conductor, so it can be traced across several AMT sections. But there are also these isolated AMT conductors that could represent massive sulfide mineralization, and an area where we have a couple of these large isolated conductors. Here was also one of the targets that were generated in the initial geophysical reinterpretation. So now we're working on better interpretation of this data. I don't think the geological map we have at the moment and the understanding of this area is sufficient for the drill targeting. I think we have underrepresented structure in this interpretation certainly as well, and we need to think about the grabens and how those normal faults, which are basement parallel, work, and what displacement there is from transfer faults there, and any other faulting that would have occurred. And we also realize that these AMT sections are spaced 500 meters apart at the moment, and if we project Enterprise onto this area, which I've done, right, this is the outline of the Enterprise ore body, it may have only been picked up by one AMT line. So probably planning on infill, and if we use IP, right, we'd add another dimension to our geophysical data. So if we had a chargeable unit that was also a conductor, that would sort of bring it up to a drill target, if we think that it's in the right stratigraphy as well. And then there's an obvious question is how far away can we get from from this contact before the lower Rhone becomes too deep to drill. Yeah, so lots of questions still to answer and lots of modeling still to do. Yeah, this is the result of this year's survey. So there is a lot of data and a lot of work to do. Yeah, one interesting thing as well is, as the luck would have it, I think one of the most important sections for us to complete here this year wasn't able to be completed because of access issues. There was a dambo there, so yeah, lots of work to do here. But I think going back to the first point we made about Ntambu when we acquired the license, right? Can we explore this area effectively through the Kalahari?
You have 5 minutes.
Yeah. Okay. Yeah, I think we have succeeded with that quite well, and yeah, we're positive about being able to progress this targeting further. And right, I've essentially only touched on the northern side of Ntambu. Right, there are three other geophysical targets left across the license, and this whole southern Graben fault. Like I said, I think that's more conceptual. Right, the idea there is, right, how far is it to basement on that southern Graben fault, and is there potential for mineralization to be hosted in a lower Rhone stratigraphy, hidden there adjacent to basement. I don't know what's the age of the fault as well. I've seen some papers that think that that this is where the Kalahari cover sort of sits in, that it could be related to East African rift system faulting. So yeah, I don't know. And I think I'll leave it there. I mean, I have slides on the rest of our projects, but I don't think we have time. I mean, you can just flick through, and Dongwei, we've generated geochemical anomalies, identified iron caps with hydrothermal breccias that we think look analogous to Katoomba. And we've also sampled some high-grade veins. And there is an active artisanal pit with 15% copper and 0.5 gram. And we've sampled up to 18.3 grams per ton gold near our licenses. So this is interesting, but yeah, these are sort of IOCG targets. Also, the geochemical anomalies corroborate with PHP IOCG targets generated in the noughties during their big concession IOCG exploration. So we're progressing with that. And our newest acquisition, Kaleni Hills, I think is sort of best, the idea of it is best summarized by this slide. That same basement edge continues to Kamoa-Kakula. Right, we're in a different stratigraphy here. Most people point this out when we show them this, right, that it's mapped as Lower Rhone, but there is a graphitic shale mapped in this area, which should be a target horizon for sedimentary hosted copper. Yeah, and I think I'll leave it there. And if anyone has any questions, shout.
Thank you, Tom. Going to open for a minute or two if anyone has any questions.
Tom, if I could ask you a question, I'm not sure what the answer might be, but what is the importance of the polymictic breccia?
For us, I think the importance is mainly as a stratigraphic horizon, right? So other work here, right? So we know that we're targeting Lower Rhone, and other work around the Kabombo Dome has shown that the polyolithic breccia never cuts into Lower Rhone; it always lies on top of it. So the simple inference from that then is, if we still have Lower Rhone in at the base of drill holes in Ntambu, right? We have an intersected Lower Rhone, so we need to do more drilling. Its direct relationship to mineralization, right? It's a halokinetic body, right? So it's salt. It's been interpreted as a salt breccia. right, which is an important control on mineralization as well. But I think, like I said, primarily for us, it's sort of an indication of where we are in the stratigraphy here.
Yeah, you shouldn't view it as a stratigraphic horizon, I don't think. If you get a COV, you get multiple intervals of polylithic breccia, and what they are basically hiatuses of where your uplifted block, the Mambula, whatever it's called, to the northwest, has been eroded into the Rhone breccia, which contains lots of ekail. So you get polylithic breccia above, below, around, everywhere within your Rhone. So I don't view it as a stratigraphic unit at all. Or anything related to salt. It's just basically where your elastostrome and your push has ceased for a moment. You've had erosion, and you've had erosion of your material, your more granitic material, off shoulders of uplifted, horsts and of domes, and that's just muddied the issue, so to speak. So very dangerous viewing it as a stratigraphic marker, I think.
Okay. Well, I'd be interested in discussing more. From what I've read from, I think the work done by Williams and Nisbet, their inference was that the polylithic breccia is never found to be crossing the lower Rhone. So
no, it doesn't, because the ekail are floating in the Rhone breccia, which contains the polylithic breccia. So by default, it cannot ever cross the ekail, and therefore by default will never cross the lower Rhone. It's something entirely different.
Okay. Okay, well, maybe we can, I'd be interested in discussing more with you. And
sure. Yeah, give us a call.
That would be helpful. Thanks.
All right.
So thank you very much for the invitation. I'm going to talk about some challenges and opportunities facing geologists in Africa, and I think obviously the more experienced geologists among the geologists that are listening to these talks will know many of these things, and I suppose this is more directed to those younger guys who are going to be taking on the mantle of discovering deposits in Africa. Unfortunately, some of the projects I'm involved in Africa are under confidentiality, so I really can't say very much about those, and therefore I've made a very generic presentation. So let's start off then. The disclaimer, don't believe anything I say. The good news in all of this is that geologists will always have a job. If you're good, focused and adaptable to change, and as you know, geologists are generally very smart people. They're far smarter than engineers that tend to sort of try to destroy whatever deposits we ever find, and then the metallurgists that complain all the time. The global population is growing, and because of this growth, and because of they're going to need increasing amounts of metals and materials to sustain society, increasing urbanization, industrialization, electrification, communications. It's almost on an upward logarithmic transformation. The world's getting richer. Wherever you go on the planet now, somebody's got a cell phone, no matter whether it's the most inhospitable or remote parts of Africa or Asia or even South America. You'll find somebody with a cell phone, and somebody knows the soccer scores or what's going on with the gold price. We're also seeing modern technology, which is requiring specialty metals. So the advent, I guess, probably for the last 10 to 50 years has been a demand for some metals that we'd read about and we'd seen on the periodic table, but really nobody took very much notice of. And this is again for those geologists like myself who are reasonably seasoned and mature. I guess you younger guys will have known, about the periodic table and what the rare earths metals are and what graphite is and the different forms of graphite. But certainly for groups like myself, we never really did a great deal of exploration for these in the past, and very little exposure at university. So there's a demand for these specialty metals, and there's also sudden technological changes that have occurred and which means that certain of these metals, and even some of the better known metals, there's certain metal price spikes, which are caused by huge demands for these particular metals. And we've seen this in the PGMs. We saw it in the early 2000s, the late 1990s, early 2000s, with the advent of the autocatalysts and the great demand for the PGMs. And then we saw that wane and the move from platinum to palladium. We saw that in the rare earth area. We saw that in the sort of 2010 and 11 and 12. And then the prices went down again, and now we start to see a resurgence of rare earth prices. And therefore, some of these projects that were, and even companies that went, that were searching for those are now revitalized. And rare earths are used in magnets, and increasingly so. Graphite, likewise, in batteries, and lithium, we certainly see a sort of resurgence in the metal prices, in the prices for lithium globally, and the search for lithium deposits, and those, lithium is used in batteries as well. So in a sense, the adaptability of a geologist is one to really try to understand very quickly, if he's tasked to find commodities, specialty commodities like this, or metals, then to understand very quickly their geology and read up in the literature and learn from conferences like this on some of those aspects of exploration and metallurgy. So geologists have to be adaptable to change, and also be cost effective. As I say, there are many mining companies and investors. There's a portion of those investors or mining companies see exploration as a huge asset for the company, or a huge benefit for investors, because we can create and discover new mines, and obviously make anything between 10 to 100 to 1,000 times an investor's money. But in most cases, exploration is not successful in the sense of finding new mines. Successful in obviously understanding the geology of an area, but the objective is to find new mines, and therefore many mining companies and investors see it as a huge liability, which is a pity. Why is exploration and mining important? Well, it's depending on what kind of figures and what kind of papers you read, it's driving up to 38% of the world's GDP, and everybody recognizes its critical role in energy transition. Even with substitution, even recycling, the world needs a great deal of metals in the future, and this is helping with obviously energy and global decarbonization. Also, to a certain extent, the geopolitical uncertainties and the COVID-19 has brought about a reappraisal of the mining supply chains, and not to rely on certain political jurisdictions. For instance, we've seen this with the gas in Europe, and the reliance of Russian gas, and then Russia goes to war with Ukraine, and then there's suddenly a supply problem with gas. We've seen this with Chinese and the rare earth blockades, which occurred around 2009, 2010, and that caused a huge spike. So you've seen recently the American government getting involved, and even some other governments getting involved in rare earths and helping funding of rare earth facilities or even rare earth companies, and encouraging the supply chain to be in safer or home jurisdictions. So in many ways, that's very, very helpful to us, because if we're in one of those jurisdictions, then obviously we're going to benefit. And then the question is, well, what commodities would be next? And I've suggested that uranium could be another commodity that is going to be coming in vogue again, and there's going to be a lot of exploration and for uranium around the world, and likely in safer jurisdictions if you're looking for Western world capital. So we realize there's not enough supply to meet future demand for the green economy. And I was at a recent conference of ministers, and you know, I posed a question, and that's all very well. You know, they're asking the ministers and committees of various international organizations are asking for a bigger commitment from exploration into mining and discovering these future metals, but in a low commodity price environment. And you know, although we've seen some increases in commodity prices, in a sense, we haven't seen the giant jumps. We've seen some in base metals, but gold is still pretty low, and obviously we've seen the huge jumps in lithium recently. But we haven't seen the general upsurge in commodity prices, largely because of global uncertainty, where we have a risk-averse environment. And so there's a big gap. There's a gap between what people perceive to be required in the future, and you know, you see graphs of electric vehicles and their uptake in various continents and countries globally. And then groups are saying we need more lithium, we need more rare earths, but then you know, there's very little money seeping into the exploration for those commodities. So there seems to be a big gap there, and largely because I think the world has been moving towards a short-term solution rather than you know, a long-term strategy, certainly for these important commodities. And I think in the near future, we're going to see a rebalance of that from some of the major trading blocks and countries of the world. So challenges facing exploration in Africa, we've got obviously the global situation, trends and risks and uncertainties. We've got exploration trends, new technologies and new terrains and countries to explore, new flights into countries where the geology looks good and it's undergone very little exploration. So therefore, it's going to be reasonably easy to find and discover different commodities. But we're hampered by this commodity price fluctuations and the boom and bust environment. You know, 1 minute you're raising millions of dollars for exploration, and then in a year or two's time, the price has gone through the bottom, and you know, you can't raise a dime for what you're trying to do, even though you may have a good project. But it obviously depends on commodity prices. In Africa, and we're probably going to hear from Boris later on you know, what Africa can do, but you know, in Africa we've got our own problems, information and the lack of information, the lack of transparency of gaining information, the cost of information, the geological data and maps. The politics seems to always be changing. Stability of governments changes. The more populist governments have gained traction, and you know, economies have suffered because they've rather gone inward rather than looking outward for you know, international investment. You know, overlying that, we've got safety issues in Africa, kidnapping, bombing. You know, there's a lot of stuff been going on in West Africa, Burkina Faso, and Mali in recent time. And I know a lot of our colleagues are, you know, working in those environments. You're finding bombing, insurrection, local violence, of no fault of the explorationists. It's just a change in government, change in environments of the local communities and people. And then obviously we've got this corruption issue, and then the question for an explorationist or an exploration company or individuals is, you know, can you legitimately operate in that country? And you know, there's an ethical situation there. There's also international compliance. You know, you can actually be put in prison for corruption, and your company can be fined very heavily, as we've seen in recent years. And then, you know, we're looking at returning investment of any exploration and any discovery that's made. And it appears that really only the high-grade discoveries currently make mines in Africa. And there's obviously a reason for that. And the reason is the high costs, the lack of skills, the lack of power, often the lack of water, infrastructure, And all those add to the cost of developing mines and operating mines. And therefore, it's only really the higher grade deposits can actually make it. You know, this is just a feature of where we are in Africa, and hopefully things will change. Infrastructure, ease of access is costly and sometimes dangerous, whether it's with private planes or whether it's on dirt roads, and it's a problem from exploration through to mining. And then obviously industrial skills base, the facilities in the country, the laboratories, you know, you're usually looking for quick turnaround on drill results. If you don't have a portable X-ray analyzer or soil samples, and then you know you may need to export your samples, and you know you don't see a result for a few months, and that can be costly and cumbersome. Local customs and language are also issues that need to be overcome, and it's up to ourselves to really understand those local customs and languages. So commodity prices, we've seen these bubbles, and over time, over the decades and over the last few centuries, and you know, and then the question is, you know, are these fluctuations normal or are they abnormal? And I'd suggest that they're actually becoming the new normal. The life cycle, we've all seen this diagram. Well, really, 2, 3, 4, 5, and 4 and 5 are just irrelevant unless geologists are given access to exploration funds to make decent discoveries. And we know we're going to fail most times, but we're pretty intelligent group of professionals, and really the front end of mine development and production. But again, we're in a high risk zone. This is a highly risky area, investment risk, time risk, and you know, and this is why you know we can make a great deal of money by making discoveries, but we can also lose a great deal of money by not doing that. But it's all part of the learning curve, and you know, we go on then to maybe make a discovery later on in our careers, or in a different jurisdiction or geology. So I was mentioning before about exploration budgets and the gap that's happening. So I guess, you know, from the mid-90s through to around 2010, 12, you know, the non-ferrous exploration budgets really used to follow the annual index metal prices. So there was a pretty synonymous pathway for those. They pretty much mimicked each other. But I guess over the last 5, 7, 8 years, we've seen this gap increase. So there's metal prices that remain low, whereas metal prices have been high, whereas the budgets have remained low. And this gap really is going to hinder exploration and discovery. And there's going to be a huge issue in the future in terms of replenishing the supply that the mines need to provide for the huge demand of huge populations coming to the earth. So let's look at exploration trends in 2021. We're really in a risk-averse environment. We've seen gold remain relatively low. I mean, you know, I remember the days of $250 gold, $300 gold, and now we're up to $1,500, $1,600. But it's still reasonably low given the inflation and given the costs of mining. But we've seen quite a big base metal surge, so that's been pretty good for the industry. Interestingly enough, money has moved. You know, Canada's attracted, you know, over $2.1 billion in early stage exploration, whereas Africa is really only attracted 1.1 billion. And you'd ask the question is, you know, what's the big deal about Canada? Is it really that mineral rich? Is it much richer than Africa? And obviously the answer is no, it's not. But it's a safe haven for exploration, you know. we'll talk about some of the issues there later. Juniors budgets increased by 4.1 billion, but largely in these specialty commodities like lithium and rare earths, particularly lithium. A lot of exploration money's gone into exploration for lithium worldwide, but the majors still drive exploration. So about 4.1 billion gone into junior exploration and 5.6 into by majors. Interestingly enough, early stage exploration budgets are all-time low globally. 24% grassroots exploration. Mine sites at all-time high at 41. And why is that? Well, anybody who's worked for a major will understand that the powers that be, the CEO of the mining company and the COO will figure that they get a better bang for their buck by exploring around the mine in mine site exploration. It's easier. It's not as always as you're not going to find often new deposits, but you can find extensions to existing mines, and because budgets have been rather tight in this period, grassroots exploration has been very low. However, grassroots exploration has increased in Australia and Canada, and pretty much reduced everywhere else. So we can see here, a lot of exploration budgets gone to the Americas and Australia. Africa's really not done very well, and the question is, why is Africa missing out? It's not for the want of having good geologists in Africa. We're looking here, this graph shows the drilling funding per region, and it shows that obviously there's a lot of drilling, and drilling really is the pointy end of discovery. Once you start drilling, you're really looking for, delineating an ore resource, an ore body, a mineralized zone. So you're well on your way to a decent discovery when you start drilling. So it's really the first advent of a discovery. So a lot of drilling going on in Asia Pacific, US, Canada, and obviously Latin America. Very little going in Africa, up to about 9%, which leads you to think there's not very much discovery or not very much exploration leading to discovery taking place in Africa, because there's just not being assayed and drilled. And then funding, so funding for exploration, and this is a breakdown of where the funding is coming from. It's largely Australia, and Australia, the funding, for Australian companies can come from all over the world, not just Australia. It comes from Southeast Asia and China, Hong Kong, Singapore, but also from London and even Canada. But likewise, Canada on the TSX, its funding comes from largely North America, but sometimes London as well. And these investors are really looking to invest in less risky countries. So let's look at global distribution of ore resources. This is not recent. It's probably about 6 years old, but it still pretty much gives a pretty good idea. And this, obviously, the size of the circles give you the amount of resources, ore resources in particular jurisdictions. And it's quite obvious that the Americas and the Cordillera there, North and South America, Australia, and parts of Europe and Asia, particularly Asia, have seen huge amounts of global resources, and Africa not so much. And I'd suggest that's obviously nothing to do with the potential of Africa. There are other factors there, and those other factors we can look as obviously I'm looking at these as challenges, but they're also huge opportunities for us. Huge opportunities, likely the least explored continent with abundant mineral resources, good geology for finding world-class mineral deposits. The challenges, though: poorest continent, most corrupt continent, most dangerous continent, most politically unstable continent, highest population growth, and least developed infrastructure. And added to this, you've got disease, poor education and skills. So all looks pretty glum, but in that comes opportunity. And, you know, we have to deal with these, you know, we have to face them as geologists. We're at the pointy end of entry into an area we are exploring, and therefore we need to be cognizant that we're actually exploring for a mine, and we're the lead group in from a company, and depending on how we behave will also determine how our successors, who hopefully will develop a project into a mine, how they are perceived and observed by local communities. But you can see here is a GDP map of the world, and you can then understand, you know, this is why social pressures are more prevalent in Africa, because basically it's low-income countries.
Sorry, Tony, you've got 5 minutes.
Yeah. So Africa is low on GDP per capita. Is this gap ever going to close? We hope so. This is a map of corruption. Obviously, it's a big concern, and Transparency International, and certainly in the West, always looking at corruption and not just government corruption, individual corruption, but these groups will track you down in a global sense. The US has started to fine companies that are involved in corruption and following up with quite hefty fines. Dangerous places in Africa, but let me move to pretty much, you know, understanding languages, population growth. How do we become smarter? I still contend that mapping is the basics of exploration. There's nothing can replace feet on the ground. The geological maps that we have are largely old ones in Africa, the colonial ones. They're generally not accurate. They're reasonably good, and you can't assume that they're correct. And therefore, it's always good to remap areas of interest and relog any core that you would find. Satellite mapping and geology and alteration and elevation are very, very useful. So modern techniques there. Airborne and drone geophysics, cheaper and more accurate, and pretty much can go in remote areas. And then we've seen advances in magnetometry, gravimetric, seismic, and many electrical methods to help us advance. And we saw this in the previous discussion, the previous talk. And it's also advances in analysis. ICP-MS is used routinely for PPB and PPT determinations. We're finding portable and accurate X-ray analyzers to analyze alteration, which is often very difficult for us geologists to see some of the alteration, very fine alteration. And then also machine learning and the use of algorithms for data interpretation and data interrogation. But how do we become smarter as operators? We're obviously in a very challenging environment. So I've listed here a few important issues. Community engagement, even before your exploration, even before you start exploration, know your community, meet the chief, get to know the people in the area, learn the language, whether it's the national language, whether it's French and you're English speaking, or it's Portuguese and you're French speaking, or it's English and you're French speaking, and understand the local languages as well, or understand some words. Understand health and safety is obviously really important in Africa. You can be bitten by snakes. You can have all sorts of normal things that can happen. You can have appendicitis. You can have a stroke, and you need to understand where medical facilities are, and you need to have emergency action plans. Employment, employ as many locals as you can and treat them as equals, because you're actually guests in their country. Communications is obviously important. Having more than one form of communication on site for safety is important. You know, cell phone networks can go down, and you can be stuck in some pretty difficult environments. Having local partners and understanding the local regimes is important. And training of locals is also important, and understanding the local skills base. Baseline community and needs study is necessary. You know, those old days where we used to just go in and just try and put a clinic together, or put a school roof, or give footballs away. And so all of those days have gone. Really, we need to do needs studies in areas where we're operating to understand where the best funding and the best needs are attended to, either by ourselves or NGOs that we partner with. governments are important. You need to meet regularly and update local, regional, and centralized government officials. They need to know who you are and what you're doing. Otherwise, they become very suspicious. And then also goes for your home countries, your embassies, your consulates, your high commissioners. Tell them what you're doing because they're your eyes and ears on the ground in terms of governmental information. And NGOs, often we dismiss NGOs, they're the greenies, they're the soft-spoken people who work steadily on some strange and interesting projects, but they can be very, very useful. They're on the ground. They're there with the communities, they're attending to some needs, and partnering with some of these NGOs can be very, very beneficial to any exploration program. So thank you very much for your time.
Yeah, okay, so I'm going to be talking to you about the link between quartz veins that we see in deformed terrains and the deformation events that affects these terrains, and try to link that with vein-hosted gold mineralization. And in this case, I'll be talking about the case study that we conducted in the Manesi Greenstone Belt in Zimbabwe. And this work is coming from my master's research, which was supervised by some of my co-authors listed here. So what tectonic veins? These are mineral aggregates that precipitate from a fluid in dilational sites. And what we see is that these are common features in the deformed terrains. And you can have several generations of these where they show clear cross-cutting relationships that you can also see in this picture here, where you see this quartz vein cross-cutting some of these horizontal quartz veins. And reconstructing their timing to see how these quartz veins are related to deformation is very important when you try to apply that sort of information to vein-hosted gold deposits. So what is the sort of approach that we can do to sort of reconstruct the timing of these veins? We can get the relative timing of these veins by doing detailed structural mapping and kinematic analysis of fabrics in the veins, and as well as in the host rocks, and also by looking at microstructural analysis of especially of quartz in these quartz veins. Or you can go a step further and do some absolute dating to try and determine the precise states of these structures. So this is the approach that we used in this research. And looking at three broad sort of classifications in terms of timing of these quartz veins, we can see that we have quartz veins which are referred to as pre-deformational veins, which you see on this first picture here, where you see a quartz vein which is later deformed by some deformation event. Or you can have syn deformational quartz veins which are forming during deformation, as you can see in this axial planar quartz vein in this folded schist. Or you can have some post-deformational veins which are forming well after your deformation has taken place. So why are we interested in this sort of technique? Is because when we look at the Zimbabwe craton, most of the gold deposits here are vein-hosted. And so trying to understand the timing of these veins and the scale of a craton, it also helps us to understand the hydrothermal activity that led to the formation of these quartz veins. And this information can be valuable to exploration of these sort of deposits. So our case study is the southeastern Manesi Greenstone Belt in Zimbabwe. This is the map of the Zimbabwe craton showing the location of the Manesi Greenstone Belt, which is shown here as this red ellipse here immediately to the east of the Great Dyke, which is a purple polygon here. And here is a detailed map of the Manesi Greenstone Belt, where you see that most of the greenstone metavolcanic rocks are outcropping on the southern part of the Greenstone Belt. And we see that the major structure within this Greenstone Belt is a doubly plunging syncline, where the southern part of the syncline is plunging towards the northeast, and the northern part is plunging towards the southwest. And these fault closures are defined by these red-brown units, which are the iron formations. And looking briefly at the lithostratigraphy of the southeastern monastic greenstone belt, we see that this part of the greenstone belt is structurally interlain by granite gneisses of various ages. Some of the ages are shown in this simplified strat column here. And structurally on top of this, we've got what is referred to as the lower greenstone series, which consists mainly of some basaltic rocks, which are locally pillared, with minor felsic volcanic rocks. And this lithostratigraphic unit is unconformably overlain by the lower sedimentary series, which consists mainly of pendidyne formations and phyllite, and which is in turn unconformably overlain by the middle greenstone series, which consists mainly of pillar basalts. And we see that these southeastern granite gneisses, they are transected by this approximately 1 kilometer thick north-south striking central shear zone here, which is referred to as the Moore shear zone, which I'll be referring to as the MSZ in the next coming slides. And so we try to reconstruct the deformation record of this southeastern part of the greenstone belt, and we see evidence of polyphase deformation, where we've got 3 deformation events recorded. And the first deformation event is recorded in both the granite gneisses, which you see in this part, and the supracrystal rocks. And this cross-section here that you see here is an interpretative section along this yellow line here. And what we see is that the first deformation event formed shallow dipping fabrics, dipping shallowly to the southwest, which is shown here in these 2 stray units. And this shallow dipping gneissic foliation carries also generally northwest plunging mineral and stretching lineation. And it is in these underlying granite gneisses where we've got evidence of dextron kinematics, which are shown here in this porphyritic leucogranite gneisses. And when we go to the supracrystal rocks, we also see development of these shallow dipping fabrics, which fold axioplanar cleavage to recumbent folds. And this cleavage, it also carries shallowly plunging mineral lineation, and also fold axis, which plunges generally from the southwest and all the way to the northwest. And we conducted some argon-argon dating to try and date the white markers that we see in the underlying granite gneisses, which are defining S1 or gneissic foliation, which is our D1 structure. And the edge that we got from this is 2688 to 2617. So this is constraining the timing or the minimum edge of D1 in this greenstone belt. And when we look at the second deformation event, which is mainly localized in the granite gneisses, and it shows a gradual strain increase from the eastern part of the granite gneisses to the western part of the area occupied by these granite gneisses. And what we see in the easternmost part of the granite gneisses is these upright folds that are developed in this case in this gray gneiss here, which are associated with sub-horizontal fold axis. And this sort of zone gradually grades westward into a zone of axioplanar gneissosity, which is steeply west dipping, and which is the result of the folding of S1. And this zone of axioplanar gneissosity, it grades westwards into the Moore shear zone, which is referred to here which is denoted here by MSZ, where we see formation of myelonitic foliation. And this foliation steeply dips to the west, and is also associated with central kinematics, which we see in this photograph. And we also dated this deformation by dating the white markers, which are defining our myelonitic foliation here in this photomicrograph here. And the edge that we got is 2588 to 2541 MA. And this edge range, and the one that I reported earlier, is coming from also the duplicates that we dated, because for each sample we had 2 subsets, so that we see if our edges were really overlapping. And then moving on to D3, we see that this deformation event again is also recorded in the supracrystal rocks and in the granite gneisses. And in the supracoastal rocks, it occurs, it formed this steeply northeast dipping axial planar cleavage to these decimeter scale folds, which are mainly preserved in the metasedimentary rocks of the lower greenstone series and also of the lower sedimentary series. And this axial planar cleavage, it also carries a generally northwest shallowly plunging mineral lineation, some corrugation lineation, and crenulation lineation. And when you look at the granite gneiss, we see that we also see this axial planar cleavage or axial planes to these open folds. And these axial planes, they also moderately dip to the northeast, and they're associated with this shallowly northwest to southeast plunging intersection lineation between these two planes. And we also conducted some paleostress analysis on some of the box folds that we see in the southern part of this shear zone. And the sort of directions that we see of our paleostresses is that this sort of box folds were associated with a generally northeast-southwest directed shortening, as we can see from this stereo net. So how then do we interpret these 3 deformation events? So the first one, we interpret it as a dextrose strike slip event, where we see a thrusting of these supracoastal rocks to the northwest is indicated by this stretching lineation that we see in the underlying granite gneiss. And in terms of these recumbent folds, we interpret them as resulting from layer parallel shortening with a component of simple shear. And these progressive folds attain their recumbent attitudes, probably because of some sub-vertical shortening, which is coming in from the weight of the overlying overburden. So that's how we interpret these sort of folds. And this sort of interpretation might be an oversimplification of what's happening here. And then in terms of the second deformation event, this is a range-dominated transgression. And why we think that it's a range-dominated transgression is because of this steeply dipping myelonitic foliation associated with this sub-horizontal stretching lineation and synth-rock kinematics, which are all consistent with range-dominated transgression tectonics. And lastly, on the third deformation event, this was associated with the northeast-southwest directed shortening. And so how do the coast veins that we see in this part of the greenstone belt, particularly the underlying granite gneiss, because we studied these veins in a bit more detail compared to the veins that we see in the supracoastal rocks. So how do they fit in all these 3 deformation events that I've just mentioned? We see that we've got what we classified as Elisine D1 quartz veins, the veins that were also formed during this first deformation event. And these veins are shallowly southwest dipping. And they're geometrically compatible with the orientation of shallow dipping gneissic foliation in their host rocks. And as we can see, this is how they can sort of be represented in these schematic diagrams. And one thing that's very important to note is the fabrics that we see in these veins. And we see that the kinematics that we see are the same as what we see in the host rocks of these veins. And so we believe that these veins were formed in the early stages of this first deformation event. And we also have another generation of quartz veins, which steeply southwest dipping. And these veins, they do not show any development of any planar fabric of some sort. And the only evidence of deformation that we see are these cataclasis zones here that you can see in this photomicrograph here. And we dated some white markers that we saw in these veins, and the edge that we got is 2634 MA, and which is overlapping with the edge of the first deformation event, but occurring a bit in the late stages of the first deformation event. And lastly, we've got another generation of quartz veins, which we see mainly in the more shear zone. And these veins, they're parallel to myelonitic foliation that we see in the shear zone. And they form these quartz ridges, which you can see in this picture here. And another thing to note in these veins is also the development of these stockworks, which probably suggests that we had more than one fluid ingress event. And because we don't see any evidence of ductile deformation in these veins, and also because of the orientation, which is also parallel to myelonitic foliation in the host rocks, that sort of evidence probably suggests that these veins, they formed later during the second deformation event. And so here's a slide summarizing the timing of veins that we see with respect to the deformation events as recorded in the host rocks. So we've got the first generation, which is shallowly southwest dipping, which formed during the early stages of D1, and steeply southwest veins, which formed later during D1 again, and steeply west dipping veins, which formed in the late stages of the second deformation event. So we can see that we've got three episodes of hydrothermal activity in this part of the Greenstone Belt. And when we try to relate that to gold mineralization, which is also hosted in the underlying granite gneiss, we see that steeply southwest dipping veins, which we said formed later during D1, which is shown here as this yellow line here. They are the ones which carry gold, but the content of gold in these veins is generally very low, which is up to about 0.13 grams per ton. And so what we can conclude from this is that it is this second hydrothermal event which was associated with gold deposition in the underlying granite gneiss. And so when trying to sort of explore for gold mineralization in the underlying granite gneiss of the southeastern part of the monastic greenstone belt, the target should be this steeply southwest dipping veins, as we have demonstrated in the previous slides. And so in conclusion, what we can say is that quartz veins, they're very common in deformed terrains. And from our case study, we can see that we've got three generations of quartz veins in the monastic greenstone belt. The first one, which is early Sin D1, the second one, late Sin D1, and the last one, which formed during the late stages of the second deformation event. And what we have demonstrated from our work is that exploration in this part of the Greenstone Belt should probably target this the late Sin D1 steeply southwest dipping quartz veins, which are carrying gold. And so constraining the timing of these quartz veins with respect to the responsible deformation events is very important when exploring for these quartz vein hosted gold deposits. And then from an exploration point of view, this sort of technique can be applied to the rest of the Zimbabwe Craton to try and understand the main hydrothermal events which are recorded in the Zimbabwe Craton, and to see which ones are associated with gold mineralization. And this sort of information can also be used in exploration. And I'd like to thank the National Research Foundation for funding this work. Thank you.
You may have seen a couple of these slides yesterday in the presentation that my colleague Guy gave. And what we're really trying to do is just entice some of you to possibly consider joining us at MSA. So this slide is to show where we've operated pretty much since our inception about 40 years ago. And you can see all the blue countries where we worked. It covers most of the world, excluding Asia. And admittedly, we haven't done a lot of work in South America, although we've done some work there. You can see on the side here, just even this year, we worked in 24 countries. Get a bit of a feel for the scope and scale of MSA. We've done over 100 projects this year, and we have over 100 staff. That's between permanent and contract staff. We're in the process of expanding quite rapidly. So you'll see these red dots. These are where we have offices. So many of you may know our Joburg office, where we've been operating from for some time. We also have an office in Botswana. We have one in Egypt and Saudi Arabia. As of this year, we've had an office in Kazakhstan. There's a lot of new work coming through from that side of the world. And next year, we'll be opening our UK office. So it's quite an exciting time, and a lot of places we're working and operating in. And so that's why we're looking to see who can possibly join us. And as those of you been in the consulting side of the business, you'll know that you get to work in many different countries sort of in a short space of time. It does make the work quite interesting. Also, we work pretty much in all commodities other than oil and gas. So speaking of working around the world, here's just a couple of photographs of some of our team. A number of these are from Africa. Two of the photos here are from South Africa. So this is from Xeris project. This is from a project down in the Northern Cape, the one on the far right. I don't know if you can see my mouse. And then the one in the bottom right and the one above that are from a project we've been working on in Kazakhstan. So Daniel, one of our geologists, has just returned a couple of weeks back from having done a drill program up there, where you can see it's pretty cold at the moment and getting increasingly colder as the weeks go by. And then this graph is really just to show the what aspects of consulting we do. And many of you will be familiar with this graph, this mining curve. And what you'll be able to see, or what you probably know, is that projects start out, they've got low value, very high risk. And then as time goes by, the risk, which is shown by this red stippled line, the risk decreases and the value of the project increases, and you go through various stages of study. And then eventually you go into production and you deplete your resource, and then you go through the rehabilitation phase at the end. And we have capacity to undertake all of these aspects of work. So at the bottom of the slide, you'll see the various potential clients. So as work starts, it might be regional exploration programs or government mapping, might be junior mining companies, private equity companies. And then as the project advances, then the banks come in, the financing comes in, and the larger scale mining companies become the clients. So we have various departments within MSA. We have our geology department, mineral resource department, mining studies, environmental, and our diamond laboratory. And so between these departments, we cover different aspects of this mining cycle. So the geology department, we typically, although we span most of it, most of our work is in the early stage grassroots exploration and early stage drilling up to resource definition, perhaps. Then the data gets passed on to our mineral resource team. So we have a team of staff who are conducting work there. And then our mining studies team, they do things like valuations, due diligence studies, audits, gap analysis, etc. The environmental team, well, they're involved with permitting right from the beginning. They monitor programs through their duration. And of course, they're heavily involved at the end with all of the rehabilitation work. And then we have our diamond studies team as well. So that's just to show that we have different disciplines, and we're involved in different aspects of this mining value curve. And as such, we're looking to see if we can get people to join us in those different areas. I'm just trying to move to the next slide, which is not happening. Let's just see if I go here. Seems to have frozen. Oh, there we go. Okay, so if we're looking for guys in any of those areas, for anybody who might be interested, we're looking for geologists, we're looking for mining engineers, we're looking for mineral resource geologists and environmental scientists. So have a look at our website, and if you're interested, then send us an email. Thanks.
So I guess probably the first thing has been raised by a number of people in the discussions is there's now growing focus on ESG, not just in the exploration and geology community, but it's getting raised in things like the UNEC, getting raised at the last Crisco AGM. So ESG is becoming front and central to anything that we do. So those of you that are involved in exploration activities, have you seen a change in the attitude of the communities and the governments that you're working in terms of that? So they're getting more rigid in terms of the requirements for mining and exploring in areas, or is it still currently that's not caught up to you quite yet? Okay, Boris, do you mind tackling this before I'm going to, I know, be nasty and ask Alex for his opinions?
Sure. I think, you know, I'm always a little bemused by this whole drive, the sudden supposed realization of ESG being such an important component, in that it is a fundamental business risk element. If the people who are hosting you have no benefit in you being there, your life is going to be difficult. And I think it's sort of suddenly become codified and got flavor of the month type status. But I suspect that prudent operators have always done it since time immemorial. What does concern me a little, though, is there's an increasing move, largely by governments, to sidestep their responsibility and place it onto the mining companies to take over on their behalf, pretty much. So they'll be looking to sponsors. The mining company must sponsor a school. And no sooner have you done it than you find that that school's funding from government, sorry, it's got a truck going past, dries up and the onus falls higher on the mining company. Similarly, maintenance of roads, and the list grows ever longer. So governments are starting to see it as an opportunity to soften their fiscal burden to the area within which mining companies are operating. And that for me is a very worrying component, because it stretches an already stretched budget to cover aspects that it was never really designed to cover, nor should it be, in that mining companies are paying their taxes, and they should be getting the services that come attached to those taxes.
Well, that actually is pretty much one of the ongoing questions I did have going through, because one of the things I did notice during COVID, just obviously monitoring the news and like everybody not being able to get out, there did seem to be a move or an excuse during the COVID lockdown period, for governments and parastatals as a general rule, to then say, well, we can't do it. Oh, Mr. Mining Company, you're sitting in that jurisdiction. You know, you're obviously generating a huge amount of capital, therefore you are now responsible for schools, infrastructure, medical care, as well as social care, which I agree is something which I have noticed, and it's not just in Africa. There's similar moves I've noticed in fact in any sort of developing economy where there's a large degree of mining, that the onus is now being placed on the mining company is almost a de facto, well, if you want to go and mine in our jurisdiction, by the way, this is going to be coming with it, but it's never really codified. It's one of those things that it's like a stealth tax. It just happens, and you've got to start agreeing with that.
And therein lies the danger, you know, in that if you know what you're up against before you start, you can budget, you can plan it, and you can work out whether your enterprise with that additional burden still can stay afloat. But when you're out swimming with your nose barely above the water and somebody puts their foot on your head, life gets a bit uncomfortable.
Well, I can sort of understand that with, I guess, taking over Salibi Piqui with, you know, lots of anticipations from local community. You know, there's massive infrastructure, which again, by default, you've now inherited all of that, which and Boris, I'm not going to ask you this, but I'm going to request someone from the audience to maybe step in here. With all the changes, and again, taking this from the ESG point of view, that are starting to come through, we all know that JORC is in the process of being updated. There's a lot of focus by the ASX on competency, but it spills over into other areas and forming potential investors in risk in terms of projects. We know there's all the discussion documents which have been going around in terms of changes to NI 43-101 as well. We've had SK 1300. The Turkish reporting standards just been updated. I was part of that review committee. They're going to be releasing that probably early next year. The Brazilian reporting code has also just been reviewed, and will be a new update is due to be released. So in terms of the general audience, have you found that reporting codes, whether it's or any of the CRISCO group reporting codes, have been a help or a hindrance in terms of the way that you do business? If so, is there anything that you would specifically like to see changed in the reporting standards, or is it just something that's now part of life and you pretty much need to deal with it, and that's what life is? Okay, I'm going to put someone on the spot then, seeing as I not feel embarrassed to make him answer and me do all the talking. So Safisa, would you be, seeing as you did attend one of the sessions for the CRISCO AGM, would you be prepared to share some thoughts on the matter at all?
For some reason, I knew you would throw me under the bus there, Mark.
Well, hey, that's what you get when you put those very flattering photographs on LinkedIn, Safiso.
Yeah, look, I need to jump off literally, Mark, for a call to finalize something. I was just waiting for a call at 2. Yeah, so I'll jump back on in a few minutes. I just need to finalize something. Hopefully it'll still be going, and then I can add my 2 cents, all right?
Okay.
My apologies here.
Yeah.
I'll be back shortly.
Okay. So, Sejo, would you be prepared to volunteer an opinion or not?
Hi, Mark. It's Wilson. Can I just?
Sure, Wilson. Anyone that's prepared to talk, I'm more than happy.
Super. Awesome.
This is Craig here.
Sorry, Craig. Wilson was going to chat, and then I'm sure I can take your question or comments after that.
Okay.
So,
awesome.
Wilson?
Thank you. I think the reporting codes they are needed, and they should just always be improved. And I mean, everyone knows about how these codes came in, the famous BRIEC story and all of those. But even today, they still help in making sure that you are differentiating real projects from those who are not real. Because even today, people still take chances, of trying to sell projects that do not exist. So because your code will guide you to a certain extent, that actually helps. And as we know, these codes differ. And I heard you mentioning all of these codes, but I didn't hear you mentioning the SAMREC code. And that could also be highlighting another thing to say in South Africa, how much of the work is being put to improve these codes to make sure that these are more stringent than before. And we know in a lot of countries these are just they are not national instruments like the Canadian one, So do we need to move to those extent where these things are also national instruments in our countries as well, in South Africa, for example? But I'm taking a long way to answer this, but the main answer is that we do need this code, and we do need to make them stringent more and more as we go forward.
Thanks for that, Wilson. Craig was going to make a comment, and then I'm going to ask Tanya for some of her input, seeing as she's part of SAMREC working committees and things like that.
We're definitely seeing an uptick in the interest in ESG, and we're seeing it in the popularity of various training courses for the codes and ESG principles. And we've actually formed a specialist division of the Geological Society to deal with it, run by Lynn Soulsby. So that's new on the ground. but I can't say too much about what's happening to the codes themselves at the moment. But going forward in the future, and given a continent like Africa, I expect that those codes are not going to be as easily internationalized compared to some of the other reporting codes. In other words, there's going to be a lot of local flavor to it, and it's going to add complexity to the exploration and mining tasks that we do, I suspect.
Thanks, Greg. Tanya, would you like to comment about anything?
Just to note that all of the codes are undergoing review at the moment. A couple have already, and the SAM codes is not far behind, where like most of the codes, each one looks at what went before to see what is the best to take out of there and implement in their code going forward. And we're doing exactly the same thing. We've seen the code that the PERC code, which has recently been renewed, and JORC, which is currently in update, as well as the CIM. And yes, SAM codes is following closely behind that. We have great difficulty in trying to decide whether it should be more stringent or less stringent, how much information needs to go into it, because you can put so much information into a code that you can produce a 3,000-page document without too much hard work. But who's going to bother to read a 3,000-page document? It needs to be useful, both to the company who is using it, as well as to the regulators and the investors. So we're trying to find a useful way of gathering sufficient information to be useful, but also having enough information so that it is not misleading. So that's where we're going at the moment. Thank you.
Thanks, Tanya. So yeah, just on that, for those that haven't seen it, there is a JORC discussion document. I think it's about 300 pages that is available for review, discussing competency and stuff like that. I admit I've not managed to get through the entire thing, but it's worthwhile reading, and it's actually got some really great references in it. So just to change direction of the discussion at the moment, and it's something that Tony had flashed up in terms of demographic growth throughout. And again, I'm going to be focusing on Africa here, as that's the topic of discussion. Demographic growth versus the lack of training and education and skills that are available in the continent. So the question that I want to posit, and this is where I'm probably going to call in, well, I guess any of the industry specialists, but also the academics that are on the call. Given the regrettable dropping, let me try and rephrase the commentary. In terms of university rankings that have recently come out, it's quite sad to see that, again, South Africa, well, African universities in general, but South African universities in specific, have continued what appears to be apparent drop down in the rankings in terms of international standards. So from people that are actually in academia and also people that are in an industry, are you seeing that there's sufficient skills and new graduates coming out that want to follow a career in the mining industry? And on that, are the skills which have been taught at university level, are they sufficient and they're up to date, or is it still pretty much the same old, and you're getting people wanting to explore in West Africa, but have only ever been lectured on the Bushveld and the Witwatersrand?
I suppose you're expecting me here, Mark?
Well, either yourself or Linda.
Okay, well, one of the things that we're noticing across South Africa is the reduced number of students in our honours classes. Several years ago, most universities would have 20 or more students, whereas places like Stellenbosch, Cape Town, UJ, and Pretoria have less than 10 honours in their honours class. So this, considering that we all need to be doing much more mining for the future, for the green economy, I think is slightly worrying. We still maintain good numbers here in Wits, but there's certainly a reduced drop in numbers across the board, in that our first and second year numbers are less than what they used to be.
Okay, well, thanks for that, Judith. I see Aurelian has joined us. Aurelian, hi, welcome.
Hi, yeah, sorry I'm late. I thought it was a bit later, but thanks. Yeah, I wanted to raise this because on multiple fronts, because I'm currently studying at the Common School of Mine in the UK, which, you know, has been shutting down or on pause some of their courses because literally the numbers dropped to zero. And you know, I've spent two weeks in South Africa, and it was great. We went to University of Pretoria. We didn't get to see Wits, but to see that there's still a big course of people, but even with the big course of students, us in West Africa, it's almost impossible to find skill sets that are, that's what I talked about early in the presentation, is that we need people that are in country, and for language barrier, it's very hard to find people that know what they're doing and I can speak French as well. So it's a big challenge because you can't also just rely on you want the best people with their skills, and regardless of which language they speak. But in the end, we're mining in countries that are predominantly French, and it's the same vice versa. And it's becoming very hard for us to find good skill sets, to the point where we had to set up a technical services in the UK. And as I said this morning, half of our team are from South Africa, which is great. But even to get these people on board was a massive struggle. So, and what we found is is even to train up people. There's good people locally, but to train them up, you need very senior and well-trained mining engineer, or geologist, or exploration or resource, and you don't get these. Also, a very rare skill set. So it's constantly on our radar, and probably it's the fault of the industry, but we don't do enough to support the next generation of mining geologists, geotechnical engineers, all those skill sets are really scarce. It's a massive problem.
Okay, just on that, and then I want to get back to, sorry, Judith, I see your hand, and I want to get back to Boris. But just in terms of that, my understanding, having the last PDAC before shut down, and then also speaking to, as part of my PERC role, speaking to people in France, places like University of Quebec or Fontainebleau, they still have graduates graduating. But are you finding that there's a lack of interest in those graduates wanting to come to Africa for whatever reasons? Or is it just a case of they don't have the skills to want to come into that area, and they would much rather get into investment banking or the ESG space rather than, walking around and hitting pure innocent defenseless rocks?
For sure, that's absolutely right. And the proof of that is, RSM in the UK, the only training that's left is a mining energy finance degree. So that's what they had to do to still survive. So yes, for sure, but there's a massive difference between, it's probably open doors, but it's between graduate and willing to go on a 6-3, 6-4 on-site in countries that are really difficult. So you can't send graduates 24, 25 years old in Mali or in Guinea or in those places, because you need a bit more gray hair or no hair at all. if you see what I mean. So this stuff.
Okay, which allows me to then, sorry, Boris, I'm putting you back on front and center. So in terms of your experience, both in the DRC with Alphamin and now moving to Botswana, are you finding it easier to get skills and people to come and work in Botswana compared to the DRC? Or was the financial attraction of, more money in the DRC just because of the conditions more of an attraction than a stable place like Botswana, where there's obviously not going to be the same level of salary because it's now a safer jurisdiction and effectively a much nicer country to work in?
Mark, I probably should plead the Fifth Amendment here, but the human capital resource in Botswana just blows me away every day I'm in touch with it. We have extraordinary engineers, geologists, technicians, right from the guys manning the pumps, the cages. It's it just is absolutely incredible whenever we hold interviews for pretty senior positions. I come away from it just going, we should hire them all. You know, it's just extraordinary. So yeah, a huge difference in just, you know, I think the human capital in the DRC was also, we would never have built Alphaman had it not been for the ability, the willingness of people to work and to learn. And we had a guy who started as pretty much a child laborer in the mines, in the mountain of Basia. And he now is the plant controller. He sits in front of 6 computer screens, never seen a computer in his life before, and he runs it. But the level of human, or rather people skills in Botswana is of graduate level, and it is exceptional. It's a joy to work with.
Just to add to that, the reason why in the UK we still have a mining course is because of students from Botswana being trained in the UK. So again, that speaks to itself.
Keep it going. You're doing a great job.
not just the UK, but yeah.
Well, that is one of the things which I find quite surprising. For one of my many sins, I'm an honorary lecturer at the Camborne School of Mines. What is quite interesting for me is how many students from Africa are going to the United Kingdom to learn how to mine, where arguably universities like the University of Pretoria, the University of the Witwatersrand, Rhodes Universities, unfortunately that doesn't seem to be as good anymore, but Rhodes University's MSc in exploration geology, there's all those skills of excellence sitting within South Africa, but people are apparently preferring to go to either Camborne or, in the case of Francophone speakers, going to places like École des Mines in Paris, which is something which I guess from an academic point of view, in fact, even maybe a geological society point of view, something worthwhile, you know, trying to understand out why. Is it the fact that University of Exeter is rated in the top 150 universities in the world, and it's a case of getting into the UK and getting work experience, or is it just a case of something else which I haven't been able to put my finger on? But it's something to, again, throw out to the general audience if they would like to opine on that statement.
I can speak about West Africa and France. I think most people most of them are already, a lot of them have French national already, or have a passport to go to France. And so it's not really you're not going to become a mining engineer or geologist by spending 1 year in École des Mines in Paris. That's for sure. So it's just a professional continuing education that also is lacking, because exactly to what Boris said, you can find people that are hungry to learn, and mining is just crushing rocks or looking at rocks in the end of the day. So you can train them on the job. It takes time, but if they're hungry to learn, they can learn anything. But then at some point you need to learn the science behind it, and like continuous education. Where do you go? And for myself, I can speak Spanish, French, and English, and I couldn't find any training that was suitable in Europe. So I went to Camborne, which is now shutting down professional course mining. And you wonder what are the options? And yes, they do prefer to go to the UK, but I don't know why, honestly, because seeing the pool of universities here in South Africa, that would make a lot more sense to stay in Africa.
Okay. Well, I really don't like trying dominating, with my questions. I'm beginning to think I'm, CIA interrogator, just throwing these questions out. So
you look the part.
Through you, Mark.
Oh, thank you very much. Have you been having private lessons with Bernard?
No, I used to be Bernard's freak show for entertainment value at the end of his various Indabas or whatever other showcase he had. He would bring me on for the laughs and giggles. This lunatic who thought he was going to build a mine in the depths of the forests while people were shooting at him. He thought it was hysterically funny. So no, I've been on the brunt end of Bernard, but hopefully not picked up any of these things.
No, well, I worked for Bernard for 7 years, which is why I was just curious. And I sat in the audience when he was asking you some of those rather interesting and pointed questions. I'm thinking it's nice to see some other poor poor sod on the receiving end of Bernard's comments.
Oh, well, you could have put your hand up then and not a couple of years later.
No, but that was then. This is now, and I'm a whole continent away from him. So, but yep. Is there anyone in the audience that would like to
Yes.
raise any comments at this stage?
Oh, yes, Mark.
Hi, Wilson. Yes, the floor is yours.
Yes. I think in terms of the point that you just made, you seeing a lot of African students in the UK and all over the world, it's mainly because of how most of these courses are structured. And I'll give you an example with let's take a vet's geology degree, for example, a Rhodes one. They more at undergraduate level until you're doing honors, they're good because they build the base of the geology that you understand. But after that, when you go towards your postgraduate level, you find that a lot of people now want to understand much more about geology and what it does until it gets to mining and the NPVs and all of those. So a lot of those courses in the UK, like the Camborne School of Mine, the other one, the Imperial one, you start with geology, they put in metallurgy inside, they put in finance, they put in mining in one course. So it gives you everything that you need to know about a mining project or about a mine. So I know at VEST they do it at the mining department. And I know many years ago, Prof. Henny tried it together with some people at Tax as well. So those are the courses that are needed. And I think once we have some of those courses, you'll then see less African students going to the UK. And what you see now, you would see a lot of geology and mining students not doing a lot of postgraduate. They'll start going to doing an MBA or do a BCom, so that it helps them to understand the financial part of the industry. So, but if those courses, which includes all of those, are structured like that in the country, you will see a lot of students not leaving Africa, staying in Africa so that they can understand all of those. So I think that's where the issue is.
Sure, thanks, Wilson. There actually is another one, and again, for my sins, I'm part of it, I lecture it. University of the Free State does a full online master's course, which tackles most of those things. Interestingly enough, I think for the first time in history, the University of the Free State is ranked higher than Rhodes University, which is an interesting state of affairs. But to try and move...
I must say, I did study that one at UOFS.
Oh, okay, so you're a fellow COFSI. So just moving the discussion on, and this is where I would like maybe some commentary from MSA, if there's anyone from MSA still available. And Alex, I'm going to put you on the spot for this one. So if you want to drop off now, this is your time to vanish into the distance. In terms of doing exploration within Africa, would you posit that it's more cost effective to use a independent consulting company, so like an MSA or an SRK exploration service, or is it better and more expedient to do the exploration in-house? So if there's anyone from SRK or MSA that's available, I'd love to hear your thoughts. And then Alex, if I could ask you if you wanted to share any of your opinions, given your AngloGold Ashanti experiences.
Yeah, it's Dave here from MSA. So what I would say is that we've actually seen quite a strong shift. Whereas a few years ago, we would send a whole big team to do exploration somewhere else in Africa, maybe 10 staff. We'd do all the logging, sampling, and everything else. But in the last couple of years, there's been quite a move towards companies saying they need to employ local staff, which is correct. And also to train up their own staff. So typically the way we operate now is we'll send in sort of one staff member who will ensure that all the correct SOPs are implemented. They'll oversee the drill program, they'll work together with the local staff. and we'll get the program running, and then they will continue working on their own, and then we'll do periodic site visits. So it's been a bit of a different modus operandi, and I think it works quite well because the local people they develop their skills, and we can also ensure that ultimately when it comes to resource definition, all the correct procedures have been put in place as you get a code compliant resource. So that's really, I think, how we see it happening. And I guess a lot of those companies also, for them, it does work out probably, well, I would hope to think, more cost effective to just bring us in to help guide the program than to hire a senior staff member to do so.
Sorry, thank you very much, Dave. Alec, would you be prepared to comment?
Yeah, thanks for putting me on the spot. I was waiting for that. Look, I think there's obviously there's a certain scale factor that comes into it, and I think in our case, it's very helpful that we are certainly from the greenfields perspective, greenfields exploration work on a sort of a global basis where we can pull together subject matter expertise, which isn't the case for many, and I think that comes to some of what Dave was talking about there, where you might want to bring in those resources that are generally expensive to hold, but not everyone can do it. So we're a pretty mature company as far as our exploration teams go, and have been in a fortunate position to be able to build up a pretty solid group of experts across the various sort of sub-disciplines of the field. So I think from our case, we do tend to do, as you know, most things in-house. I think it's always nice to get the seal of approval from established consultancies who can, it is occasionally frustrating how sometimes that appears to bear more credence than what we might be telling our superiors internally sometimes when it comes with a nice stamp on it. But nevertheless, I think on the whole, we're certainly comfortable doing a lot of the work ourselves in-house. But I do appreciate that it's very much a scale issue. I think and for us, we're in an interesting position because as far as greenfields goes, sort of putting back into Africa now, but a lot of the time we are very much focused towards operating around where we have operating mines, and obviously that brings with it quite a strong support network that we can leverage off as well. So I think that really helps in our case. But having been in consultancies before, I can certainly see the arguments where you don't have those established infrastructures in place.
Thanks, Alex. And I had to put someone on the spot from a major company, and yours flashes up with AGA. So, Boris, Aurelian, would you guys like to comment from sort of, wouldn't be rude and say more junior positions, but from a more nimble type of company approaches? Would you be prepared? No. So Aurelian first, and Boris, if you would like to, put in some commentary as well, please.
Yes, no, that's fine. We're very small. I mean, I think the biggest barrier is the legal that you mentioned, Mark, and today in Guinea, they've just passed, or yesterday, a law that forces you to have 100% of your unskilled workers locally, 75 with skilled workers, and 50% even up to the management team. So to be able just to comply legally to a drilling campaign will be a massive pain for someone running a global consultancy business. So that's the first thing. The second point is, for a junior company, our only added value is really geology. So outsourcing geology, other than to do a check for consultants, I think it's really, really hard. And everybody on our level, they want me or even the CEO, everybody to have 100% grasp on the geology. And it needs to be over time as well, because the cycle of junior mining space, you might have money 1 year and you still need to stick around for 3, 4, 5 years. So if you have a consultant running the exploration, then you're going to pay a retainer for 4 or 5 years. It just doesn't work from the structure of the contract for a junior mining company. And even in production, we gave our we've tried once to outsource everything, the drilling, the interpretation, and with the budget, and there's so much education on our specific deposit that you have to make, and adjusting with the operation, that it takes a lot of time. So you're this trade-off where you might want to keep the skill set internally rather than explaining to somebody else that might not be there in 2, 3, 4 years time, when you actually want to dive back into the data and understand what they've done once they've done it. So that's the other big issue I see from a very small perspective.
Okay, Boris, if you would like to comment, if you don't mind.
Yeah, no, I'd certainly agree. I think, historically we've used a combination of both. So you have a senior geological house team working with your guys on the ground, who would be generating the data that is being fed into the models and into the thesis, which is controlled largely by some of the more senior consultants around. And we found that combination works very well, particularly to get your sign-offs for whatever stock market it is you happen to be working in at that point. The data being generated is aligned to what is required, both to corroborate the thesis and to populate your resource statements as they need to be. Unfortunately, junior mining it's an IP generation business, and your cost is total meters drilled by total cost for that year. And you better make sure that every meter drilled counts. Otherwise, the costs do go through the roof very quickly.
Thanks, Boris. And I think both of you have led Sage very nicely into the next point of discussion I would like to raise. Mr. Deploy, I'm going to put you on the spot for this one as well, if you don't mind. So moving into data, I mean, as a consultant, I've been doing consulting for 15 years now, and one of the things that always perturbs me is going to a client and saying, well, what data do you have? And the client will invariably give you a dump of stuff which has not been collated not everybody, but in general, there'll be a dump of stuff. The database is in an Excel spreadsheet. They would be blithely unaware of any previous exploration work that's been done. No one has bothered to go and search like Widespace or any of the online facilities to see if any PhD or MSc work has been done. No one's been to ResearchGate to see if there's any other information available. But the point of that ramble is, would it be considered an advantage if the states, and I'm using this as a general term, had databases available like Canada and Australia, which are free, so you can get a level of information, whether it's regional geophysics, regional geochemistry? Would that be a competitive advantage to an African state to attract investment? Or, as Boris pointed out, because you're an explorer, this is your IP, and you'd much rather prefer to go in and stay under the radar, do your own thing. If the project doesn't work out, walk away, but you're taking that IP with you. So it's not going to give somebody else that advantage moving into that space and being able to take the data that your company has acquired at major expense and extrapolate that data, and over time then make a new discovery, which I guess is based on the work that you've done in the past. So I guess from the question I'm going to ask Megan is, your view of data and databases. Is the industry, or have we moved on from 20 years ago where everybody was still using Excel spreadsheets, or have we actually managed to move forward into something which is a robust database? Okay, Megan is not going to raise that one. So I guess, Alex, if you want to, or if anyone else wants to, Ariel.
Yeah, I can start. So I think most companies are still using Excel spreadsheets, and you'll see Mark very shortly. We are still using a lot of Excel spreadsheets, but that's the core. That's the way to be efficient. And this morning, lots of people asked me, how can you make a mine with 0.75 gram a ton work and make money from it? And it is to have a very precise understanding of your geology, which comes through consolidating all databases in one place, having not only your internal team, but consultants looking at it left, right, center. So it's very cool. And to this point, the first thing that we've invested in is a CRM system before even having a DFS in our mind to control costs, to control data, to have full transparency on all our costs. And we're going to be doing the same for geology, because that's critical. And that's the only advantage you've got, because once you have the property, it's yours. Nobody's going to take it from you unless they want to pay a silly price. So the only thing is to work this property as best as you can. And it's operation, but that's comes back to the people and the skill set, and it's understanding your geology, which can only go through a unified vision of everything from exploration, grade control, production data, surveying, all the way to truck optimization, to product specification, and that will need to be in a big data warehouse somewhere, and that in some ways simplify the skill set shortage, because anybody in the world, and that's why people set up technical services outside the mine side, because you can work from anywhere, and you can tap into a consultant in Australia that's been specialist in West Africa. You need from a couple of hours, and boom, you can log in, and so that ease the workflow and ease the analysis of data. So I think it's absolutely crucial. That's the first, even before drilling, that's the first thing people should invest in, is a proper database system to gather all the data.
Okay, Boris, do you want to make any comments?
Yeah, Mark, I was going to go ask you whether I can have my cake and eat it. In that, should the countries make all historic exploration data available? Absolutely. Do I want to hand it over to everybody? No, absolutely not. But in the greater scheme of things, if one is not going to be pursuing a project going forward, then it seems a bit like dog in the manger to be sitting on the data that you're not going to be using. But I do see, we spent 11 years looking at projects in Africa to back with some pretty serious money. And inevitably, the mistakes you highlighted were mistakes we'd see over and over again. People would come in with data, but they hadn't cross-referenced it back to studies that exist, to interpretations of the geology of those areas, in order to ground it and present it as a potentially investable opportunity. Now, one must bear in mind that only 1 in every 3,000 mineralized discoveries becomes a mine. So if you have a mineralized opportunity that you believe can get there, you're doing it an injustice if you aren't cross-referencing it to every bit of information that is there. That's both geological, metallurgical, economic, logistics. When you walk in front of somebody for whom you're going to be asking to invest in your project, you need to really understand it, and you can't understand it on your data alone. These projects are too big, they're too globally connected in so many respects, economics, various metal trends, everything. So the more data you are able to present, but do not present it, remember, what you're selling is an opportunity. You're not selling your geological knowledge. So how does all the stuff you know and viscerally understand translate into an investable opportunity for the person on the other side of the fence? And the more references you have, and don't read them out verbatim, but do work them into your argument and work them into your understanding of, is what you're looking at really what you think it is? And are there other people who thought the same? And if they didn't, that's fine. But why should your thesis carry more weight than what theirs did? So I think the access to data, historic and that which is being generated post the company deciding that either that they're not going to pursue it, I think should become available.
Well, thanks, Boris. Because there are arguments that, for example, Australia and Canada, just with the way that data is archived and the rules and policies and procedures, which have allowed both Australia and Canada to continue to grow the mining industry at the same time as their economies are moving from primary industries into sort of service-based industries, because that data is available. though I think Stefan's points are valid. And Stefan, would you be prepared to sort of expand on the points that you've posted in the general chat?
Yeah, I think I mean, I spoke to the director of the Geological Survey, and he explained that while the countries are giving away information, like and the jurisdictions like Canada and South Australia, etc., they have a relatively high GDP, far more well-financed agencies, whereas in Africa and in Nigeria, it's a totally different story, and they need more money to survive, and consequently they feel it's their right to sell the information as opposed to just give it away. I mean, for instance, when I was up there, I actually did a one-day seminar on training geologists to map and evaluate small ore deposits, a very low-key technical approach. And I gave this seminar free for a whole day. And then I wanted to suggest to sell it to them for a small amount. In fact, they've just produced a brand new, with Beat Consultants, a brand new tectonostratigraphic map for the whole country at 1 to 2 million. It's a brilliant piece of work, which the NGSA themselves haven't paid for. It's come under what they call the Mindiver project, which is funded by the World Bank. And yet they will be selling that for the map and the digits, I think for about $50–$60, something like that, which is not a lot, but you would have thought that kind of information could be easily available for free. But while I see their point, anyway, the bottom line was that I wanted to exchange my information, my whole presentation, for that, because I could see they weren't willing to buy my presentation. They gave me the platform, and it was good exposure. And yet I'm wondering whether they really appreciate, because I mean, if you don't value something enough, I mean, are you going to steward it well? And I think that's a major problem in Africa. It's the way we steward things. You don't steward something if you don't truly value it. And if you don't steward it, you can't multiply it. And that's the story in Africa. And then, of course, the other thing is, and I see this DRC and other places, that information that is residing in African government agencies, such as the Ministry of Mines or Geological Survey, is often manipulated for personal benefit. And I want to touch on what Thomas Gomeric hinted at, because I know of a company that I was involved with them at one stage. They were involved drilling a copper prospect in Zambia, and they did a fantastic. They suddenly hit a really excellent hole, and then their Zambian partners, who they were working with, didn't submit documents for renewing of the license, but instead the license was cancelled and then issued to another company that was hastily formed, involving these other partners. So there was clearly corruption and greed behind the scenes there. So I think these are the kind of issues that are faced in certain jurisdictions. And until you get people that are willing, or government agencies and people in charge that are willing to operate in a more transparent manner and realize that there are benefits in giving away information, especially in jurisdictions that are higher risk. And I don't think that certain governments in Africa are aware of the risk perceptions. Well, they are aware of risk perceptions, but not willing to take the risk themselves of sowing information so that they can reap more freely. I mean, Nigeria is a classic example. If you look at the areas of their basement and their greenstone granite terrains, the area of greenstone granite terrain in Nigeria is probably larger than that in Ghana. Yet why is their gold, commercial gold industry so small? There are probably 1 million plus artisanal miners operating in the gold mining in Nigeria. And if there were opportunities to form commercial mines, if there were lower risk, I'm sure it could probably begin to catch up countries like Mali and Burkina Faso and Ghana. So that's my perspective on the situation in that part of the world.
Thanks, Stefan. Sorry, who shared the screen?
It's Ian.
Hi, Ian. Do you want to expand?
Yeah, sorry, this is something that got sent to me from RPM a little while ago, but it was actually a presentation given in Mongolia quite a while ago. But the message is, you know, building on what Stefan said, is you got to take custody of it. You got to foster this thing, and it takes at least 10 years to get this going. So these were well-funded, well thought out programs that Australia and Canada instituted a decade ago, and they're now seeing the fruits of it. It's not rocket science, right? But the only way they're seeing the fruits of it is that they've made all of this data that the taxpayer has paid for free. And unfortunately, what we have in our country is the CGS is becoming the de facto exploration or consulting arm for Chancellor House. That's really what's happening. So all of the information that has been collected over the last few years is very difficult to get hold of from the CGS, but we know that it's freely available to people in the ANC and in Chancellor House. And that's not right. That's paid for by the taxpayer. That should belong to everyone. So unless that changes, we're not going to get past where we are right now. The SAMREC system is, or whatever they call it, is the least of it. That's just a scab on the top of the whole problem. The problem is this, is that unless you make a concerted effort to generate data and then you give it away freely, you'll never turn on this engine like Australia and Canada have done. That's the point.
And so something we haven't mentioned, but the more information you make available to everyone, we have a massive artisanal mining, and I'm sure in DRC is the same. So the minute anybody discloses information, and not alone as a listed company, we use the tools that are amazing, like Verify or to give full transparency or geophysics, and they will, you know, the minute you release it, the next day you have thousands of people on site. So it puts a massive amount of pressure on the operation. So from the government perspective, if they had to invest this kind of money in a system, they probably will be better invested in a strong legal system that you can actually action to have your rights respected. So I think we like, I mean, Africa is obviously it's developing country. So if you put the exact same system that you have in Australia and Canada, it's going to be, well, first they don't have the money, but it's going to be a bloodbath. I'm pretty sure, at least for the country that we work in, Mali and Guinea, it's going to be a free-for-all kind of a thing. So yeah, it's a big disclosing information. Even on the day-to-day, we're talking about geological map, but day-to-day drill results as well from surface. We try to make sure it's not fully localizable locally, because otherwise we'll have this issue. So maybe it's a broader question of releasing information to the public and public companies operating in Africa, but it's certainly it's a day-to-day issue.
Well, it's also population density, right? So there's a very good reason people are exploring in Australia and Canada and in Mongolia and in Namibia. Is because here, you know, the moment you start exploring, some chap and his lawyer, you know, jumps out of the nearest bush, and then you know, everything grinds to a halt. So, you know, population density is a major problem. How do you respect the rights of an exploration company that's gone through all the effort of getting the data, you know, getting targets together, and then drilling and trying to build up a resource? How do you legally guarantee those rights? That's one of the nuts we have to crack. We've got to do it.
Yeah, I think that's right. I mean, you can't distinguish security of tenure from release of information. Absolutely. I don't think any of us would dispute that it would be a lovely idea in theory, and also talks to some of the ESG piece as well. I mean, what's more wasteful than people coming in and doing the same work again and not having full access to data? But until you tackle that, the security of tenure piece, it's going to remain a problem.
Yeah, I've got a very detached and kind of caustic view on data. Well, data is data; it's a bunch of numbers. It's how you treat that data and how you interpret it that really counts. So who cares if everyone has all the data? It really does boil down to the brains that apply themselves to it. So I don't see what the big deal is with governments hoarding data. One of my big beefs are these World Bank and IMF funded and BRGM, projects, Mira, etc., WAXI. Those things are closed loops where they say they're doing it for the benefit of the company, of the country, but they're not. They're doing it for the benefit of their own little research group, because they're the ones that generate papers from all these things and have little sidelines where they're on the boards of various exploration companies that do JVs on the ground. So, fine, Europe, pay your money to these schemes, but what's happening is there's kind of a, if you like it, and excuse the word, colonization by stealth of these countries, because it's a very closed loop. The revenue from those future projects in 10 or 20 years' time flow back to the companies listed in Australia, Canada, and Britain. So is that good? I don't know. Maybe someone can tell me.
Well, Ian, that does lead me into my next point, which I want to raise, and this is going to be my last point, because I'm sure everybody's getting sick and tired of listening to me talk. And I'm sure we're getting close to the end of session, and it's a Friday, and everybody is thinking about the cold beer is going to be pretty nice round about this stage. So I guess my last question then is probably contentious, and maybe people don't want to wade in on this one, and I'm fully appreciative if no one wants to comment on this. But talking about colonization by stealth, we know, and it's common knowledge, it's just not widely discussed, is that China has a long-term plan, China 2050, as part of the Belt and Road Initiative, effectively to start mobilizing Chinese soft influence along historical trade routes, which going back several hundred years. And what we are seeing is Africa is being one of the largest beneficiaries of Chinese bank loans. And so for those of you that aren't aware of it, the way that Chinese investment tends to work in not just Africa, but any of the places where they're developing the Belt and Road Initiative, is the Chinese Development Bank will grant a government X amount of money, invariably in US dollars. If that government cannot pay the money back when the loan becomes due, what they tend to have to do is provide something in kind. So you'll find, for example, if you do a bit of research, that countries like the Gambia, who weren't able to pay back the cost for the new airport, they've had to cede effectively the forestry concessions to China. Other countries have had to cede the fishing rights to China because the government has been unable to repay those loans. So the point I'm trying to get to is, as explorers in Africa, are you seeing a significant influence of China coming through, getting to security of tenure type thing? And the fact, would you, as companies who have to operate by transparency rules, whether they're Crisco group, the Crisco regulations, or things like IFC guidelines or World Bank guidelines, do you see that as giving, effectively putting you on the back foot in terms of when you're competing for a land package where there's a potential Chinese influence? Or is it something which has changed over time and you're not seeing that degree of influence from China coming into Africa, and the dynamics has shifted into something totally different? For example, getting money out of COP20, was it be COP27 now, like Cyril Ramaphosa is wanting several, was it $1 trillion to allow South Africa to go green? So have you seen a change in the dynamic, or is it still very much China's effectively moving in very low key, and that is the situation which everybody has to deal with, and it's just part of reality of doing business in Africa?
Well, I think it's certainly been a huge part of what has been going on. You've got to roll it back a bit, in that the US decided that they would outsource all manufacturing to China. China, in a quid pro quo kind of agreement, decided that they would underwrite the US debt to put the money into the American consumers' pockets to buy the Chinese goods. China then ended up with a huge balance sheet of American debt, American cash, really, dollars. And I think legitimately they decided to do a bit of portfolio diversification, and they do look far further ahead than Western companies do. We've so focused on next quarter's earnings that they're looking 5-10 years down the track. And they figured, what do we need to keep our engines going and keep our economy going? And they need raw materials. So they started investing, converting the dollars they had into hard assets, being up and down the coast or up and down Africa. And certainly their presence is ubiquitous. We've seen them everywhere. However, these things don't remain static. And, you know, recently we've seen Canada fire some pretty serious shots across the bow of China Inc. by forcing them to divest from Canadian listed companies, who some of them had assets that weren't even in Canada. So, you know, the fight is starting to become a bit of a schoolyard brawl at the moment. I do know that in the DRC, particularly parts of the DRC, Chinese companies are actively, or Chinese operators, investors, entrepreneurs are actively withdrawing from certain areas. And it is said that there's huge US pressure to replace them. So I think, you know, the problem with our industry is we don't have time horizons that are quarterly or even annual. Our time horizons are decades, and an enormous amount can happen in the world in terms of change of politics and change of materials usage, financial stuff. And it really is up to us to ensure that we have a very sound business that we build and run carefully so that it can endure these things. Do they have an advantage by not being subject to all the rules, regulations, and oversights that we do? Absolutely. Is it an advantage that I would want to use to get a business I was involved in going forward? Absolutely not. You know, I don't believe one can have a sustainable business if you are going to short circuit ESG, or if you are going to go to the level of bribery and corruption. Your business is going to fall over. It's just a question of time. So yeah, they do have an unfair advantage, but it's not one that I would like access to. So, you know, I think the movie is in play, and it's by no means cast in stone at this point.
Yeah.
Thanks, Boris. Sorry, Aurelian, once you finish, sorry, no, once you finish, Judith, I can see your hands up. So once Aurelian's finished, I'll hand over to you.
Well, Judith's been raising her hand for like 10 minutes, so maybe she can go first.
Okay, Judith, if you would like to talk, please.
Okay, I was in Zimbabwe in September, in the far northeast, where there's a lot of gold mining going on, and the Chinese are in there and they're buying the gold, but they're not, as Boris said, they're not adhering to any of the ESG or codes of practice, and they're just taking the money out. Whether the country is gaining any advantage, I don't know. But the local people certainly aren't, because they complain that the Chinese are doing nothing in the way of giving workers housing or improving the roads. And in one case, we went to a lithium prospect where the mining or the prospecting rights were with one company, and we went there and we found people loading up zinwaldite into a wheelbarrow, and we asked them what they were doing, and they said, oh, they were selling it to the Chinese. So the Chinese didn't even own the ground that these people were mining. So I find it very worrying going around in various countries and seeing the way that the Chinese are treating the locals, which is not good.
Thanks, Judith. Appreciate your comments. So, Aurelian, do you want to comment?
No, I think Boris is absolutely right. We're not in the same league and same universe in terms of assets, and I've looked at many assets in Africa, and you say this is a Chinese asset for many different reasons, because they have access to to capital, or if they have access to cheaper money, which reduce in the end your cut-off grade. Obviously, if you give me a 0% cut-off grade, we'll find gold mines anywhere and everywhere. So I think this is, and as a listed company, raising and doing it in a proper way, I'm not sure the proper way, but at least having transparency, you just can't operate their assets. So it's just definitely not doable. So that's on one hand. And as a junior, when we raise money, the main problem we face, we're raising money at the moment for our project, so it's not big, but you have Chinese interest, is that it's not just money that they will lend to you, is they want you to use the whole suite of construction, of equipment, of technology, which has two problems. First is it would not be, believe it or not, in line with local content we're talking about, because they have to bring all the people and machine and engineers in country, which they can do, but you're not being in compliance with the same country. And second, the operators, it'll be even harder to find skill, and the technology they bring in terms of equipment and processing is not up to the standards that we used to as well. So most people, even in the operation, will be very, very reluctant to use an all-in Chinese manufactured mine, which is usually what they ask for that kind of money. So it's on both sides, on the project side and on the finance side, they operating in a completely different league, unless there's a strategic rationale, like CMOC and DRC, where they've got a lot more money than anybody else, and so be it. At the end, it's unfortunate, but they win because they've done this, they've played this game and have a long-term view. And unfortunately, we have, as Boris said, a quarterly view for not just mining companies, I think government as well. They have maybe 2 years, maybe, or 18 months, or 60 days, like in the UK. But it depends. What's your view horizon?
Well, I think it's 44 days for our last prime minister, if I'm not mistaken.
Sorry, 44. Yeah, I lost track. Yeah, sorry.
So I'm going to, I guess, throw the floor open now, because I'm sure that you're pretty much tired of listening to me talking, and I'm sure that as I said, everybody would appreciate the chance to knock off early on a Friday and grab that cold beer. So are there any general comments from the floor that anyone would like to raise at all?
Yeah, I've got one, and this is an experience that's happened to us 3 times. Once on the Biani mine, which was a large carrot was dangled by a Chinese firm to buy the operation. Due diligence required them to hand over all their data. They duly did. And then it was a matter of 2 weeks, and they lost their mining right for some technicality. There was a lot of legwork to do to go back to the minister and say, look, this is not right. You need to reverse this decision, which they did. But just a heads up, if there's a large carrot dangled in exchange for all your data, just be very careful about handing it all over. We've seen clients run into this wall before. So just be very, very careful.
Thanks, Ian. And then Aurélien and Boris, I'm going to ask you for some concluding remarks before I hand over, I guess, to Craig for you to finish off the exploration conference. So I guess going alphabetically, Aurélien, do you have any concluding remarks you'd like to make, please?
Yeah, maybe. I think that the most critical thing in all that is shortage of labor, whether it's to keep all the skill sets in Africa, or whether it's to I wouldn't say fight, but in finding investment, have a long-term view. I think this is what we're missing in Africa, is just upskilling people and keeping more in country, because there's nothing like having a local intelligent skilled workforce that can actually decide for themselves. So I think it needs to happen now, because we don't have time. It's pushing everybody over the cliff, kind of. So it's a constant struggle to operate in Africa, and they have great resources. I think the reason why Canada and Australia were now a mining powerhouse is maybe because they have a good infrastructure, but also because the geology is incredible. And Boris being in DRC, geology in DRC is world class. So Africa has the world class geology, and so you can have world class mine and world class infrastructure and world class people as well.
Thank you very much. Boris, if you would like to make concluding remarks, please.
Well, I'd just like to continue what Aurélien was saying, in that the one thing you cannot change, or at least we haven't worked out how to change it yet, is the geology. And governments, economies, booms and busts will come and go. Geology remains. And Africa has by far and away the greatest unexplored potential of any continent in all of the minerals that the world needs, particularly moving towards the sort of green energy push. So there's definitely a boom coming at some point. Will it come in the next 2 years, 5 years? I don't know, but mines are wasting assets. The more you mine, the less you have for the future. They have to replace them. The world has to replace them. And the only place I think that has the capacity to do that is Africa. So keep learning, keep in touch with who's doing what, understand which of the explorers are following which commodities, how they're progressing. And that knowledge will be extraordinarily valuable sometime within our lifetimes, that is for sure, but I just don't know how soon. I think it's going to be sooner than we all think, but hopefully it is the case.
Well, thank you, Boris, and everybody. Thank you for sitting through all the presentations. Thank you for sitting through the session as well. I realize it's not quite what I anticipated or planned, but that's reality.
We've had a very positive 2 days, starting with Ellen Clegg's keynote speech on net zero and how impossible it is for us to actually quantify what the resources will be required to achieve that net zero. And he gave us some doom and gloom together with some positives on what we actually have in Africa. We followed that by Boris's presentation on Premier Nickel and how they reignited Botswana's Selebi Pikwe mines. That's just quite positive from Boris, and knowing Boris, it will probably be a success, just as we saw with Alpha Min not long ago. We then went over to Mike Ray from EarthLab, who shared the Aurora project, which was a bushveld deposit, which was also quite interesting. Nchaka also shared about his Northern Cape project, taking it from exploration and to production, which was quite an interesting view on South Africa, as we know that South Africa is not even considered as an exploration destination, and for him to be able to go through all of that, and after 500 million rands has been spent on that project, for him to actually deliver a product to the market, that was remarkable. Mark Bennett also shared the Chilo Heavy Mineral Sands project in Malawi, which is also something that's quite interesting. As we know, the heavy mineral sands are quite integral to our day-to-day lives. We also had Stephen, who shared the Fungue Belt, the Mozambique project, which was quite also interesting. All I'm gathering here is that we've actually gone across all jurisdictions except for maybe Egypt and East Africa, which we probably will have next year. We'll just have to look for those type of projects. And tech, Dr. Ian Basson, thanks as well for sharing that complex geology in the Central African Copper Belt. We learned a lot also from Michelo's Luso Global Mining Mavio West project in north of Angola. It's been quite a good 2 days. Today we started off with Michael Cronwright with CSA Global, who shared the overview of lithium deposits, and we had a battery metals section in the early stages of the day, where we had Matt Mullins also share about the southern Namibian project that he was working on with Acacia. We see a good future for lithium, and we hope to develop more lithium projects. As we know, there's a lot of LCT pegmatites around southern Namibia, Northern Cape, Zimbabwe, and the one that Mike also referred to, which is the Manono project. We then came back with Prof. Kubenga to introduce us to West Africa and what they're doing with the GSAF, which is quite interesting, uplifting geologists, upskilling. And we then had Aurelien share what they are doing in West Africa, and kudos to you, Aurelien, and thank you for sharing with us what your company has achieved, Robex Gold and also Sycamore in Guinea. We then came back south with Tom Gimrek, who shared about the Zamareb copper project and ignited some quite some interest in what Zamareb is doing, and showing how First Quantum has been so supportive to them, sharing data, supporting them, and helping them solve their geoscientific issues that they were facing with geophysics, and even understanding the ore body, which is a good success story there. Dr. Tony Harwood then took us through the challenges and successes that he's observed in Africa, which was quite a good lesson, especially for those who are looking to explore Africa from junior geologists, to understand the environment, and also remember that I like what he said about when you get to the site, you are equal with the people you are working with. The locals are your equals. Always remembering that you are a guest and you must meet the chief before you do anything, which is quite cool. And it's needed because there's so many rituals that we know in Africa. When you do get to a site, you can't just start digging around looking for samples and rock and chipping away at the rock outcrops. Brian also shared quite an interesting research that he did with UJ on the gold mineralization in the Akin Greenstone Belt in Zimbabwe. This is also something that ties into the discussion that we had now with the amount of gold in Zimbabwe and how the Chinese are taking advantage of that, and also teaching us how to actually upskill and protect our own assets. Coming to the panel discussion, thanks so much, panelists. We tackled a lot of issues there. Thanks, Mark, for those questions. And I would love to bring our appreciation as the GSSA and to everyone who joined us, and say to you, hopefully next year we'll have it in person, and we'll be having beers now. But yeah, see you guys then. And any other comments or questions?
Just thank you for organizing it. It's a bit last minute for me, but thank you, it's great.
Thanks, Aurelien, and thanks for your participation. I mean, we started talking, I think, this week or last week, and you were a key part of the event. Thank you so much.
And I'd like to add just thanks to our sponsors for helping us with this. We couldn't put on this event without them. So thank you very much.